On October 29, 2025, every telescope pointed at the sun went blind for exactly 38 seconds. Not from malfunction, not from interference, but because something passing between us and our star didn't want to be seen. When the instruments recovered, the object had moved, but not where physics said it should be. What you're about to hear isn't science fiction. It's documented data from NASA ESA and observatories' worldwide data that suggests we may have witnessed the first confirmed interstellar object performing a controlled maneuver in our solar system. Understanding what happened at Perihelion could fundamentally change how we view our place in the cosmos and what else might be traveling between the stars. The Solar and Heliospheric Observatory Parker Solar Probe and Solar Orbiter 3 independent spacecraft, separated by millions of kilometers, all lost the same 38.2 seconds of data at the exact timestamp 1426 IO4 UTC. The probability of simultaneous failure, astronomically impossible, yet it happened. But here's what keeps astronomers awake. When the object reappeared, it had changed. Its surface, its rotation, even its chemical signature, all transformed in those 38 seconds of darkness. So what happened during that blind spot? And more importantly, what was it hiding? Tonight we journey into one of the most perplexing astronomical events of our generation. We'll trace the path of 3I Atlas from its mysterious arrival through its solar encounter, examining evidence that challenges everything we thought we knew about interstellar visitors. This isn't just about a comet. It's about the question that has haunted humanity since we first looked up at the stars. Are we alone? And if we're not, are they watching? Long before telescopes, ancient civilizations tracked wandering stars, objects that moved against the fixed celestial sphere. The Sumerians called them wild sheep of the sky. The Maya incorporated their appearances into prophecies of transformation and renewal. The Egyptians believed they were divine messengers, celestial boats carrying souls between worlds, manifestations of the gods traveling through the eternal night. These weren't superstitions born from ignorance. They were observations refined over millennia. The Maya calculated Venus's synodic period 584 days, with an error margin of just 2 hours, over centuries of observation. Without telescopes, without computers, just patient watching and mathematical brilliance that encoded cosmic cycles into stone temples and bark paper codices. When Halley's Comet blazed across European skies in 1066, it was woven into the Bayeux Tapestry as a harbinger of conquest. The Norman invasion succeeded, and the comet became legend. But in China, astronomers had been recording that same visitor for over 2,000 years, tracking its return with such precision that they could predict its appearances generations in advance. They called comets broom stars, sweeping clean the old order to make way for the new. The ancient Chinese understood something profound. Comets were not random. They followed paths. They returned. The universe, despite its vastness, had memory. On December 28, 2019, the Atlas Telescope System in Hawaii, Asteroid Terrestrial Impact Last Alert System, detected a new object. It appeared first as a faint smudge moving slowly against the background stars. Initial classification: periodic comet, unremarkable, one of dozens discovered each year. But as more observations accumulated, something became clear. This visitor was different. Its trajectory was hyperbolic. That single geometric term carried enormous implications. A hyperbolic orbit means the object wasn't bound to the sun. It hadn't formed here. It came from somewhere else, entering our solar system at velocities that could only mean one thing: interstellar origin. Interstellar. The word itself carries weight. It means an object born in orbit around another star in a planetary system we've never seen under conditions we can only imagine. Ejected perhaps by gravitational chaos during planetary formation, or flung outward by a near pass of a companion star. For millions of years it traveled through the void between stars through distances so vast that light itself takes years to cross them. until finally by chance or design it fell toward our sun. 3I Atlas became only the third confirmed interstellar visitor. The first was Oumuamua, that enigmatic elongated object that tumbled through our system in 2017 and sparked years of debate about its nature. The second was Comet Borisov in 2019, more conventional, clearly comet-like, reassuringly normal, and now 3I Atlas. Statistically, astronomers estimate that one interstellar object passes through the inner solar system per year. Most go undetected, too faint, too fast arriving and departing before we notice. The ones we do see are accidents of timing and position cosmic lottery wins. Each one is a messenger from another stellar neighborhood, carrying information about chemistry formation processes and conditions in alien star systems. But 3I Atlas carried messages more complex than chemistry. From the beginning, the anomalies accumulated. Spectroscopic analysis, the technique of splitting light into constituent wavelengths to identify chemical composition, revealed something unexpected. Absorption lines corresponding to nickel tetracarbonyl, a volatile metal organic compound with the formula NiCO4. This shouldn't exist in natural comets. Nickel tetracarbonyl forms only under specific conditions. Carbon monoxide gas in contact with nickel metal at moderate temperatures, typically between 50 and 60 degrees Celsius. On Earth, it's produced industrially in the Mond process, a technique for refining nickel discovered in 1890. It's toxic, unstable in sunlight, decomposing rapidly under ultraviolet radiation. Yet here it was, detected around an object that had been traveling through the UV-saturated vacuum of space for potentially millions of years. The presence of this compound raised immediate questions. Was it being continuously produced? If so, by what mechanism? Natural comets don't have catalytic surfaces or temperature regulation. They're chaotic aggregates of ice rock and dust, primordial rubble left over from planetary formation. They don't synthesize compounds. They merely release what's already frozen within them. Then there was the orbit itself. 3I Atlas traveled retrograde backward relative to the planet's motion around the sun. Most objects in our solar system orbit in the same direction, a legacy of the spinning disk of gas and dust from which they formed. Retrograde orbits are rare, usually indicating capture from elsewhere or gravitational scattering. For an interstellar visitor, retrograde motion wasn't impossible, but it was notable. The object's velocity vector pointed to an origin in the constellation Lyra, the same general region that birthed Oumuamua. Two visitors from the same neighborhood, separated by 8 years, both behaving strangely. The ancient philosophers asked, if we live in an infinite cosmos, must we not eventually encounter evidence of other worlds? 3I Atlas arrived like an answer written in ice and stone, but what question was it responding to? As the object approached the sun through the spring and summer of 2025, observatories worldwide prepared their instruments. Perihelion. The moment of closest approach was calculated for late October. At that distance, a mere 0.31 astronomical units from the sun's surface, the heat would be extraordinary. For context, Mercury at its closest approaches 0.31 AU. This visitor would skim nearly as close, exposing itself to temperatures capable of vaporizing most volatiles. Astronomers expected a spectacular show, massive outgassing as frozen ices sublimated directly from solid to gas, tail formation as solar wind swept released particles into long glowing streamers, perhaps fragmentation as thermal stress cracked the nucleus. These are the death throes of sun-grazing comets, violent and beautiful, captured in countless images by solar observatories. What they got instead was something no comet had done before: precision where there should have been chaos, silence where there should have been screaming, transformation where there should have been destruction. But before any of that could be understood, first came the darkness. The 38 seconds when every eye watching suddenly couldn't see. In archaeology, the most revealing discoveries often come from what's missing. The gaps in pottery tell stories of how vessels were used. Erased inscriptions reveal power struggles and revisionist histories. The tomb that was entered and resealed speaks of secrets considered too dangerous to leave exposed. October 29, 2025, gave us a gap in the astronomical record, and like ancient erasures, what it concealed may be more significant than anything it revealed. Perihelion occurred at 14:26:04 UTC. At that precise moment, 3I Atlas reached its closest point to the Sun, 46.4 million kilometers from the surface of our star. This is the moment when solar observatories capture their most detailed data, the moment when objects are brightest, hottest, most active, the moment that defines whether a comet survives or disintegrates. The Solar and Heliospheric Observatory transmitted its raw feed, continuously capturing frames every 12 seconds. Redundancy systems overlapped with the Parker Solar Probe and Solar Orbiter. If one instrument failed, another would fill the gap. That's the design philosophy. That's why a simultaneous blackout across all three is nearly impossible unless something external caused it. When analysts at the European Space Agency began aligning the feeds, they discovered that all systems, despite operating on independent clocks, had gone blind at exactly 14:26:04 UTC. For precisely 38.2 seconds there was nothing. No light, no transmission, no telemetry. Then, as if nothing had happened, the object reappeared, but not quite where it should have been. The trajectory plot didn't match perihelion predictions. 3I Atlas emerged with an altered vector less than 1/10 of a degree off course, but enough to catch attention. The orbital curve calculated days earlier suggested a clean exit along a predictable path. Instead, it emerged slightly deflected, as though something had nudged it mid-pass. At that proximity to the Sun, only two things can alter a comet's course: asymmetric outgassing, when jets of gas fire unevenly from the surface producing thrust like tiny rockets, or an external force, a collision, a gravitational interaction, something applying momentum from outside. Thermal models of 3I Atlas predicted minimal jet activity during perihelion. The heat was simply too intense for sustained volatile-driven thrust. Any outgassing should have been chaotic, explosively random, not precise enough to produce such a neat deflection. So what caused every observatory to go blind for the same 38 seconds and then resume recording an object slightly off its predicted path? To understand the significance of that absence, you need to know how tightly these systems are synchronized. The Solar and Heliospheric Observatory transmits data continuously. Redundancy systems overlap with Parker and Solar Orbiter. Instruments operate on atomic clocks accurate to nanoseconds. For all three to fail simultaneously, it means the failure wasn't internal. It was external. Normally, such an event would show up in magnetometer logs. A burst of electromagnetic interference strong enough to blind multiple spacecraft should create massive spikes in magnetic field measurements. Solar wind data should show turbulence. Background radiation should surge. But no spike appeared. Solar wind remained stable. Background radiation constant. No flare. No coronal mass ejection. The Sun was quiet. Some within the network proposed an internal synchronization fault, a software bug perhaps cascading across connected systems. Others quietly pointed to something else, a temporary signal override, a data jam, as if for those 38 seconds, all instruments had been blinded by something between themselves and the Sun, something close enough and deliberate enough to mask its own appearance. In other words, 3I Atlas might not have been just passing by the Sun. It might have been doing something while we couldn't see. At the same moment, the visual feeds dropped. Several radio telescopes logged a brief, high-frequency spike at 2.29 gigahertz. It lasted less than 2 seconds, but was detected on multiple antennas at the Allen Telescope Array in California. The source direction near the solar limb consistent with 3I Atlas's position. It was later dismissed as cross-channel bleed from a terrestrial satellite. But when analysts retraced orbital alignments, no active satellite matched that vector at that time. Whatever the signal was, if it was a signal, it originated near perihelion. That's when people began re-examining the missing frame with new eyes, not as a failure, but as a mask. If 3I Atlas emitted or reflected a burst of energy strong enough to saturate detectors, it could easily knock multiple instruments offline temporarily. The systems would interpret it as noise and discard the frame. But the timing was too perfect, the blackout too complete, the return too smooth, like something that wanted to be unseen just long enough to do what it needed to do. When the feeds came back online, the first visible frame showed the object elongated, not spherical, but stretched as though part of it had expanded or rotated during the blackout. The brightness pattern had changed too. Before perihelion, the coma, the cloud of gas and dust surrounding the nucleus, had been uneven, flaring to one side. Afterward, it was symmetrical. The reflectivity had doubled. That's not how dust behaves after solar heating. Dust scatters randomly. Brightness becomes more chaotic, not more ordered. But that is how a surface behaves after shedding a layer. Astrophysicist Jean-Marie Lafont from the Paris Observatory called it a structural transition. He compared it to the way spacecraft deploy radiators after a high-energy burn. His words were careful, technical, but the subtext was unmistakable. 3I Atlas looked like it had done something mechanical while we weren't looking. NASA refused to comment publicly. ESA released a brief note calling the loss an expected data anomaly due to high-intensity light interference. Yet internal correspondence leaked 2 days later told another story. In one email, an engineer wrote, "We didn't just lose the frame. We lost synchronization across all nodes. It's as if something commanded them to go dark." That line was quickly redacted from subsequent releases. If you chart the object's brightness curve, the data paints an eerie picture. Just before the blackout, brightness increases exponentially. Then total silence. When it resumes, the brightness drops by half, but spectral readings show more metallic reflection. Less gas, more solid surface reflection. That shouldn't happen in a natural comet. When gas vents, brightness spikes. When it stops, reflectivity falls. Here, it did the opposite. One possible explanation, a surface layer of volatile material burned off completely, revealing something underneath. Smoother, harder, more reflective, possibly metallic, possibly structured. It's not proof of anything artificial, but it's a deviation so clean it doesn't fit with random fracturing or ice sublimation. In every known case, fragmentation after perihelion creates chaos, uneven brightness, diffuse plumes, dust tails scattering unpredictably. 3I Atlas did the opposite. It became more stable, more compact, more geometrically coherent, as if the heat didn't destroy it, as if it triggered it. The Dogon people of Mali speak of Sirius B, an invisible companion star they couldn't have observed without telescopes, yet they described it centuries before. Modern astronomy confirmed its existence. They claimed their knowledge came from visitors from the sky. Sometimes the most sophisticated information arrives wrapped in the most primitive explanations. The missing frame is not absence. It's presence disguised as nothing. It's a measurable, structured void. The same duration across independent observatories, synchronized recovery, altered telemetry afterward. When confronted with these coincidences, you can only stack them so high before the weight tips the balance. Either the universe pulled off an incredible series of random technical glitches, or something intentional occurred at perihelion. The data gap is not the anomaly. The precision is. And yet there's still one unanswered question. If the blackout was caused by the object itself, what mechanism could produce that kind of interference without any detectable energy surge? Some researchers suggested magnetic shielding. Others proposed an electromagnetic pulse caused by sudden solar interaction. But one idea kept resurfacing, sitting uncomfortably between science and speculation, that the missing frame wasn't an accident. It was a cover, The moment something activated, when the data was reviewed later, subtle alignment shifts appeared. A change in the orientation of its jets, the angle of its tail, even the core spin, as if 3i Atlas had adjusted itself in those 38 seconds. Whatever happened, it left behind patterns that defy coincidence. And it's those patterns, subtle, mechanical, deliberate, that lead directly to the next anomaly. Because right after the missing frame, something else emerged in the data. Not darkness this time, but heat. Extraordinary, impossible heat. Ancient alchemists believed the sun was the great forge, a cosmic furnace capable of transmuting base elements into noble ones, lead into gold, corruption into purity, death into eternal life. Modern physics dismissed this as mystical thinking, medieval fantasy disconnected from reality. But on October 29, 2025, something near the sun underwent a transformation that looked eerily like transmutation. When the data feeds returned after the blackout, the first thing analysts noticed wasn't visual. It was thermal. Instruments across multiple observatories recorded a sharp, instantaneous spike in temperature during the precise window when 3i Atlas vanished behind solar glare. The readings didn't match any known model of cometary heating. For a brief period, the object's thermal profile exceeded what carbon-based compounds could withstand. It wasn't sublimation, the normal process where ice turns directly to gas. It was something else entirely. The Parker Solar Probe registered the anomaly first. Its particle sensors detected an unexpected surge of infrared radiation centered around the exact coordinates of 3i Atlas. The spike lasted under 2 minutes, yet the thermal rise was extreme, almost as if the object reflected sunlight directly back toward the sensors instead of absorbing it. Normally, a comet at Perihelion is a frenzy of vaporizing ice-shedding mass chaotically as solar heat boils its surface. But the heat signatures here were clean, sharp, directional. It looked more like a mirror flashing light than a dusty nucleus reacting to solar energy. ESA's solar orbiter picked it up next. Its SPICE spectrometer, an instrument designed to measure extreme ultraviolet emissions, logged spectral lines inconsistent with standard ice and dust composition. The thermal gradient peaked at over 1,700 Kelvin. Well beyond the tolerance of organic compounds and typical silicates. At that temperature, any volatile substance should have vaporized completely, leaving nothing behind but inert dust. Yet 3i Atlas emerged intact, its coma shrinking rather than expanding. That single fact contradicted everything we know about comet behavior near the sun. The closer they get, the more they disintegrate. 3i Atlas did the opposite. It became denser, more cohesive. The thermal spike didn't just surprise observers, it confused their instruments. Radiometric sensors briefly reported negative values, as if heat had been absorbed faster than the sun could supply it. Some at NASA's Goddard Space Flight Center suggested this was due to an uncalibrated gain shift, but a few others quietly pointed to something more peculiar. A possibility that 3i Atlas might have briefly emitted or redirected heat in a controlled pattern. That hypothesis wasn't published. It was mentioned in an internal note never meant for public eyes, where one engineer wrote, "If this was natural, it's the most efficient radiator ever observed." As the solar orbiter's readings poured in, scientists began mapping the thermal profile frame by frame. What emerged was disturbing symmetry. The heating was not distributed randomly across the surface. It concentrated along a band wrapping around the equator of the object, as if encircling it. The band brightened sharply, emitted an intense infrared flare, then vanished entirely. Afterward, 3i Atlas's surface reflectivity increased, suggesting that whatever burned or vaporized in that belt left a cleaner, more uniform material beneath it. It was as though a layer had been deliberately stripped away. At first, the event looked like a phase transition, a natural metamorphosis under extreme heat. But even then, comets don't reorganize themselves in such an orderly fashion. Ice doesn't sublimate in perfect rings. The probability of spontaneous symmetry is effectively zero. This left researchers with a troubling choice. Either accept a coincidence of cosmic precision or entertain the idea that something in or around the object was responding actively to the solar environment. Independent analysts tried to reconstruct what could produce such thermal coherence. Some theorized it was differential albedo reflection, highly reflective patches alternating with dark material creating feedback loops of heat. Others, less convinced, speculated that if 3I Atlas contained metallic compounds, the reflection could create localized heating zones capable of mimicking control. But the problem with both ideas is time. The thermal cycle was too fast. It initiated, peaked, and cooled in under 90 seconds. That's shorter than the reaction time of any known natural feedback mechanism. Something accelerated the process. The oddest part was how silent it was. The Parker probe's plasma detectors expected a blast of ionized particles during such a temperature surge. There was none. No outgassing, no plasma arc. The object's surrounding space remained eerily calm. In a natural scenario, the heat would rip volatile gases free, creating turbulence. Here, the opposite happened. Temperature up, motion down, energy without chaos. It was then that data from Earth-based observatories arrived. The Mauna Kea telescope in Hawaii and the Atacama facility in Chile, both observing in near-infrared, reported identical findings. A brief pulse of heat matching the same coordinates and timestamp. That synchronization across thousands of kilometers is virtually impossible to fake. Something real emitted or redirected that energy. And yet, when the light returned to normal, the comet's trajectory showed a minute deceleration, as though part of its motion had been countered, slowed, or redirected. Heat and deceleration in tandem. In rocketry, that combination is familiar. It's called thermal braking. Most scientists refuse to entertain that comparison publicly, but in back channels, the term appeared repeatedly. Thermal braking implies intent, using heat to alter momentum. And though it's tempting to dismiss as science fiction, the math doesn't lie. A concentrated burst of energy along one axis could produce a measurable adjustment in velocity even in a small body. The trajectory data suggested exactly that. A minute change, consistent with thrust, too subtle for a natural explosion, too sustained for random outgassing. To grasp how unusual that is, consider the solar radiation pressure acting on any body near the sun. The closer an object approaches, the stronger the force, but it's always repulsive, pushing outward. Yet after Perihelion 3I Atlas's deceleration implied resistance, as though it were pushing against that force. There's no mechanism in nature known to reverse radiation pressure. None. Unless the object somehow reflected light in a non-isotropic way, directing its output like a sail adjusting its angle to the wind. If that happened, it would explain both the heat spike and the change in velocity. But that introduces an even stranger implication: control of orientation. Astronomers at Caltech compared the polarization vectors from before and after the event. The orientation of 3I Atlas shifted by about 12 degrees. That doesn't sound like much, but for an interstellar object under no known torque, it's enormous. The direction of maximum reflection changed, aligning exactly with the solar vector, like something adjusting to face the source of heat, rather than flee it. The Iron Pillar of Delhi stands in India dating back 1600 years. It weighs 6 tons and is composed of 98% pure iron. It doesn't rust. In 16 centuries of exposure to monsoons and humidity, it has developed almost no corrosion. Modern metallurgists can explain it. High phosphorus content creates a protective layer, but they cannot replicate the purity achieved without modern smelting techniques. Sometimes ancient materials possess properties that challenge our assumptions about technological progression. Still, most agencies stayed quiet. Official reports described unusual solar scattering behavior. A few astrophysicists hinted privately that it resembled a specular reflection pattern, the kind you'd see on smooth metallic surfaces. But calling something metallic in an interstellar context opens a door few are willing to walk through. Within 24 hours, online speculation exploded. Forums began comparing the readings to those of Oumuamua, the first known interstellar visitor detected in 2017. That object, too, had shown unexplained acceleration without outgassing, prompting years of debate. But 3I Atlas was different. It wasn't accelerating, it was stabilizing. Where Oumuamua tumbled unpredictably, this object seemed to correct itself, like a system maintaining equilibrium. Natural fragments don't do that. Artificial ones might. The thermographic data continued to circulate quietly among international teams. Several independent research groups attempted to simulate the event using comet models. None reproduced the spike's shape or symmetry. The only way to approximate it was to assume that the surface material changed reflectivity mid-event from dark to mirror-bright within seconds. That's not erosion, that's transformation. Some called it coating loss. Others used a more charged word, shedding, because if the outer layer was indeed volatile, its complete removal at perihelion could have been intentional. A designed reaction to solar proximity, a way to protect what lies beneath. In that sense, the temperature spike wasn't a problem at all. It was a function. The silence surrounding the event grew heavier with each day. Agencies stopped publishing real-time updates. The solar orbiter's temperature telemetry was suddenly under review. Parker's data pipeline was paused for recalibration. But by then, private networks had already archived the numbers. The spike happened, the heat was real, and whatever its cause, it wasn't random. Every pattern observed since then traces back to that singular moment. The flash that wasn't supposed to exist, the temperature that shouldn't have risen, and the stability that shouldn't have followed. It's the kind of signature that forces you to choose between two explanations. Either nature found a new way to organize matter under extreme heat, or 3I Atlas did exactly what it was built to do. And just as the world began to debate the meaning of that heat, another anomaly appeared. In the frames following the spike, a new jet of material emerged. Not chaotic, perfectly linear, pointing away from the sun. It didn't spray like a vent, it aligned like a thruster. Nature abhors a straight line. Rivers meander through landscapes following gradients of least resistance. Lightning branches fractally seeking paths through ionized air. Even light itself bends around massive objects curved by the geometry of space-time. So when astronomers observed a perfectly linear jet extending from 3I Atlas holding steady for 11 minutes, as the object rotated, they faced a philosophical crisis. How do you explain precision without intent? When the first post-perihelion images of 3I Atlas were analyzed, the discussion about heat quickly gave way to something even more unsettling. The jets. Every comet vents gas and dust when it nears the sun. Those jets are chaotic, uneven, and unpredictable. Like geysers firing at random angles, each shaped by cracks, fractures, and buried pockets of ice. The direction varies with rotation. The intensity fluctuates wildly. Comets don't have nozzles. They have wounds that bleed volatiles into space. But the images from late October didn't show chaos, they showed precision. In the sequence taken by ESA's solar orbiter between 1428 and 1441 UTC, a thin, bright plume extended cleanly from one point on the object's surface directly away from the sun. Its axis remained perfectly straight for several minutes, holding steady as the object rotated. Normally, a comet's spin would cause plumes to sweep, bend, or scatter. As the surface rotates, jets curve like water from a spinning sprinkler. Instead, this one stayed locked like a stabilizing jet maintaining orientation. At first, teams assumed an alignment artifact, a trick of perspective, where the angle made a curved jet appear straight. But further analysis showed the jet's direction was constant relative to solar north, not the camera angle. That meant it wasn't an optical illusion. It was real, and it was deliberate in its geometry. The plume wasn't diffusing into space like typical gas. It was collimated, narrow, focused, as though shaped by confinement. This was when the comparison to known comet activity broke down entirely. Standard comet jets expand at about 20 to 200 meters per second, dispersing rapidly as they leave the surface. But the brightness profile of this one suggested acceleration. The farther it extended, the more uniform its intensity became, like a stream maintaining cohesion. One astrophysicist in Madrid compared it to an ion exhaust. The phrase didn't appear in the final report, but it circulated quietly among data analysts. The physics didn't match outgassing. To sustain a linear jet under that kind of solar pressure, the material would have to be ejected with precision, as if through a nozzle. Some scientists proposed that the jet was the result of an unusually deep fracture, channeling volatiles in one direction. But even that explanation required a degree of structural order that seemed improbable for a natural body battered by heat. A fracture would widen under thermal stress, causing the jet to spread. This one narrowed. Then came the timing issue. The jet activated within seconds after the thermal spike, the very same window that produced the missing frame. That synchronization wasn't lost on anyone. A heat event followed by directional ejection. Cause and effect, one event leading to motion. If it were a natural process, the odds of both phenomena aligning that cleanly would be astronomical. NASA's Jet Propulsion Laboratory simulated various venting models to see if sublimation alone could replicate the pattern. None fit. Gas should spread unevenly. Tail curvature should appear within minutes. The jet's brightness should decay exponentially as density drops. Instead, 3I Atlas's emission stayed constant for nearly 11 minutes, then stopped abruptly. The cutoff was too sharp to be random. It was like a switch had been flipped. To some observers, this was the point where curiosity turned to discomfort. The object wasn't behaving like a fragment of ice and rock reacting passively to sunlight. It was performing a sequence, a thermal flash, a straight jet, a trajectory correction. Each phase following the previous one as if scripted. When the Parker Solar Probe's field sensors were cross-referenced with the timing of the event, another pattern emerged. During the jet emission, a faint magnetic pulse was detected, localized and transient, centered at the object's coordinates. The signal wasn't strong enough to indicate an electrical discharge, but it hinted at electromagnetic interaction. Natural gas plumes don't produce that kind of signal. Metallic ions might. If the material vented was ionized metal vapor, say nickel or iron-carbon compounds, it would explain both the reflectivity increase and the collimation. Ionized particles can be shaped by electromagnetic fields, but that leads to a more difficult question. What created the field? A few researchers proposed an induced magnetic sheath formed as the object interacted with solar plasma. That's plausible, but still doesn't account for the precision or directionality. Others whispered about the possibility that 3I Atlas's internal composition wasn't random, that it contained conductive veins or structures capable of guiding emissions. Those ideas never made it into official statements. They lived in encrypted group chats between astrophysicists who didn't want to risk their credibility. Meanwhile, the public data feed remained silent. ESA's published thermal and spectroscopic readings skipped over the relevant minutes entirely. The explanation given was data corruption due to high dynamic range. But the timing was too specific. Every missing data packet corresponded precisely to the jet event. It began to look less like corruption and more like omission. The one independent source that managed to capture partial imagery was the Solar Terrestrial Relations Observatory Stereo A. Its coronagraph recorded a faint trace of the jet in ultraviolet light. The spectral analysis later showed an emission peak inconsistent with water vapor or carbon dioxide. It aligned more closely with ionized nickel, a rare signature, but one that had already appeared in previous spectroscopic readings weeks earlier. That consistency was troubling. Nickel shouldn't exist in such quantities unless 3I Atlas carried heavy metal compounds inside, and those compounds shouldn't vaporize in such an ordered way. It hinted at layers, not random mixing but stratified structure. as if the object had been built, not born. The timing, direction, and spectral composition together painted a picture too coherent to dismiss. Something about the perihelion passage had activated a reaction that looked coordinated, and that reaction produced thrust. A small one, yes, but measurable. After the jet event, orbital calculations showed a subtle yet definite deviation from the predicted escape trajectory. The object's outbound path shifted by about 0.03 degrees. That's enough to change its long-term destination by millions of kilometers. What's more, the jet pointed opposite that deviation, exactly as if compensating for solar momentum. It wasn't drifting randomly into a new path, it was steering. By the evening of October 30th, several private astronomers began voicing what institutional scientists wouldn't: that the data resembled propulsion, not in a cinematic sense, not flames or engines, but something simpler. Thermally induced vector control, the kind of maneuver you'd expect from an automated probe adjusting course through natural forces using nothing but light and gas. The Inca built walls at Sacsayhuaman, where stones fit together so precisely that not even a blade can slip between them. No mortar, no tools we understand. When asked how their ancestors achieved this, indigenous Andeans simply say, "The stones remember how to fit." Perhaps precision isn't always about technology. Sometimes it's about understanding what materials want to do. If that idea sounds far-fetched, it's worth remembering how 3I Atlas entered the system in the first place. Its inbound path was already bizarre, hyperbolic, retrograde, unnervingly precise. Its alignment with the ecliptic plane was within a margin too small to be random. And now, during perihelion, it seemed to be demonstrating control, the one thing no natural body should have. But here's where the story deepens. Just after the jet ceased, the object's spin changed. Its rotational axis shifted, but not because of impact or breakup. It realigned itself slightly smoothly toward the same vector as the jet had pointed. That's not coincidence. That's adjustment. For those studying the event in real time, it was like watching something wake up. It had withstood the sun's heat, shed an outer layer, released a controlled burst, and then stabilized. Not destruction, activation. The implications were staggering, yet no one could say it publicly. Too many reputations, too much protocol. Agencies defaulted to technical language. Non-gravitational perturbations. Post-perihelion venting, thermal outgassing symmetry, phrases designed to explain without admitting. But behind the language, the unease was spreading, because if the jets weren't random, if the heat wasn't spontaneous, and if the missing frame wasn't coincidence, then 3I Atlas wasn't just reflecting sunlight, it was responding to it. And as the object began to move outward from the sun, another signal anomaly appeared. This time, not visual, but radio. For a few minutes, every telescope tuned to the object's coordinates fell silent. Not interference, not static, just absence. A perfect, calculated silence that arrived exactly when the jet disappeared. In 1977, the Big Ear radio telescope at Ohio State University detected a powerful narrowband signal from the constellation Sagittarius. It lasted 72 seconds. The astronomer on duty, Jerry Amon, circled it on the printout and wrote, "Wow," in the margin. The signal never repeated. For nearly 5 decades, it has remained the most tantalizing hint of extraterrestrial intelligence. The signal from 3I Atlas was different. It didn't scream, it whispered, and it never stopped. The first reports of the radio blackout came quietly buried in telemetry summaries that most analysts would have ignored. It began as a faint disturbance across deep space, monitoring arrays, a brief flicker in the signal-to-noise ratio that seemed to coincide with the end of the jet event. Then, without warning, the line went flat. No static, no distortion, just nothing. A band of pure silence cutting through the spectrum like a knife. The phenomenon lasted barely 90 seconds. But it didn't just affect one instrument, it hit across the board. The Allen Telescope Array in California Jodrell Bank in the UK and the FAST Observatory in China all reported identical drops. A total collapse in the signal from 3I Atlas's direction. Normally, when something goes quiet in deep space frequencies, you still hear the background. Solar wind hiss, cosmic microwave fuzz, electromagnetic clutter from 1,000 sources. But this wasn't that. It was as if a small section of the universe had gone mute. What startled the teams wasn't only the suddenness, but the precision. The blackout aligned perfectly with the object's coordinates. The rest of the sky remained normal. Every frequency outside the 2.2 to 2.4 gigahertz range behaved as expected. Only that narrow band one often used for deep space communications had gone dark, and it came back just as sharply as it vanished, like a switch flipped twice. Engineers at JPL initially assumed a solar burst. The sun can easily overwhelm receivers during perihelion events, but the Solar Dynamics Observatory saw no flare, no coronal mass ejection, no spike in solar radio output. The sun had been calm. The blackout wasn't coming from it. It was coming from near the object itself. When ESA cross-referenced timestamps from the Solar Orbiter and Parker's solar probe, something even more unnerving emerged. Both spacecraft logged subtle fluctuations in ambient electromagnetic fields at the exact same moment. The readings weren't high enough to trigger alarms, but they showed a consistent pattern. A drop in baseline noise, followed by perfect stillness. Instruments designed to hear chaos were suddenly deaf to it. Then, just as the silence reached its deepest point, 3I Atlas's reflective signature shifted again. Its albedo dropped as if its surface had darkened. In the same instant, the radio silence ended. It's rare for astrophysicists to call anything impossible, but the combination of events bordered on that. A controlled thermal spike, a directional jet, and now a synchronized communication blackout. Random natural phenomena don't stack that neatly, yet the more evidence accumulated, the more official channels retreated into vagueness. NASA referred to the radio drop as temporary interference from plasma scattering. The European Space Agency used the phrase signal saturation event. Neither matched the data. There was no saturation. There was nothing at all. The strangest aspect wasn't what was lost, but what filled the void when the signal returned. During post-event analysis, astronomers noticed faint, rhythmic fluctuations embedded in the noise floor. Too structured to be natural, too weak to classify as data. The intervals repeated at 0.187 seconds, roughly 5.3 hertz. Not random, not harmonic, just steady, like a heartbeat buried under static. Independent observers from the SETI Institute picked up traces of the same pattern, but hesitated to interpret it. Cosmic signals can imitate rhythm through coincidence. Most turn out to be instrumentation echoes, pulsar interference, or terrestrial contamination. But this one had one key difference. It appeared only in the exact window after the silence lifted, and it repeated across multiple observatories separated by continents. Even accounting for atmospheric distortion, the synchronization was uncanny. If this was interference, it was coordinated. And if it wasn't interference, it was something else. At this point, most data teams were already stretched thin. The observatories were receiving more attention than ever, not just from scientists, but from intelligence agencies monitoring the situation. Requests for raw telemetry skyrocketed. Private research networks found their access quietly revoked. Certain data channels went offline for maintenance. The timing was again remarkable. Inside those networks, analysts began whispering about an uncomfortable hypothesis, that 3I Atlas had emitted something during perihelion, a pulse, a transmission, or an electromagnetic response triggered by the sun's energy. Not a message in any recognizable sense, but an action, a deliberate silence followed by a signal. The kind of pattern you'd expect from a device, protecting itself from overload, then rebooting. The theory found an unlikely supporter at the Beijing Astronomical Observatory. Dr. Wei Han, a plasma physicist, noted that the silent band coincided with a rapid drop in ion density near the sun's limb, that he suggested could only happen if an external electromagnetic field momentarily disrupted local plasma. In other words, something created a bubble of quiet, a zone where charged particles couldn't interact. He called it a radio shadow. Others called it a shield. When this finding leaked, it reignited the same debate that surrounded Oumuamua 8 years earlier. Back then, unexplained acceleration was the mystery. Now it was absence. Absence of heat, of light, of sound. Intentional quietness. But there was one key distinction. 3I Atlas wasn't just passing through the solar system, it was reacting to it step by step in real time. To test whether the silence might have been caused by Earth-based interference teams, cross-checked data from the Mars Reconnaissance Orbiter, which had been observing the sun's far side during the event. Even from Mars's vantage, the blackout registered faintly in the signal logs. That ruled out any local cause. Whatever happened, it was happening near the object itself. When the silence ended, something else shifted. The object's spin rate, constant for weeks, suddenly slowed by a measurable fraction. It wasn't much less than 0.02 rotations per hour, but it was precise, consistent across every instrument. Some suggested the loss of angular momentum resulted from outgassing, but there was no corresponding material emission, no debris, no plume. The object had simply changed its behavior as the silence broke. The silence then wasn't just a gap in data. It was a turning point, a before and after. Before the blackout 3I Atlas was active, flaring, ejecting material. After it, the object became cold, dark, reflective. A mirror drifting outward in eerie stability, as if something inside it had completed a process and powered down. In the days that followed, the frequencies around 2.3 gigahertz showed faint, periodic ripples. Weak, almost subliminal, repeating every few hours. Some speculated they were residual solar echoes. Others thought they were telemetry. None could explain why the ripples decayed at the exact rate of the object's outbound velocity, as if trailing behind it like a signal fading with distance. The Pythagoreans believed that celestial bodies produced music, the music of the spheres, inaudible to human ears, but mathematically perfect. They weren't being poetic. They were describing orbital resonances, the 2:3 ratio between Jupiter and Saturn, the 2:5 ratio between Venus and Earth. The universe does sing. It sings in mathematics. Officially, no agency acknowledged the silence. The incident vanished from press briefings, replaced by generalized comments about routine anomalies. But in the archive data sets, the silence remains. A perfect, inexplicable void surrounded by noise. The kind of absence that feels engineered, not accidental. And when investigators tried to trace its boundaries, they discovered something even stranger. The silence wasn't perfectly horizontal on the spectrograph. It curved slightly, following the object's trajectory as if anchored to it. A band of quiet moving with 3I Atlas as it turned away from the sun. That shape gave the event its name, the Silent Band. It wasn't just a momentary blackout. It was an orbiting shell of silence traveling with the object like a cloak. For hours after the event, receivers pointed directly at it, heard less than they should have. Not interference, but suppression, a deliberate muting of space itself. Whatever caused that quiet wasn't finished, because within days, new data from ground-based telescopes revealed a second anomaly. One buried not in sound or heat, but in light. Something in the way 3I Atlas reflected sunlight had changed. Its polarization signature, once stable, was now inverted. The kind of reading that suggests a surface structured, not scattered. But hidden within that inverted light was something even more unsettling. A tone, pure and clear, at exactly 440 hertz, concert pitch A. The note used to tune every orchestra on Earth. Medieval alchemists sought the philosopher's stone, a legendary substance that could transmute lead into gold, cure disease, and grant immortality. Kings bankrupted treasuries funding these searches. Scholars devoted lifetimes to arcane texts and experimental furnaces. Modern chemistry dismisses this as fantasy. Transmutation, we now know, requires nuclear reactions energies far beyond what medieval laboratories could achieve. Yet at Perihelion, 3I Atlas performed a chemical transformation that defied every known model of comet behavior. It consumed carbon dioxide and produced nickel compounds, all while hiding the one element that should have flooded space oxygen. When the spectral data from the post-perihelion period began streaming, and the first thing scientists expected to see was a surge in volatile gases, especially carbon dioxide. Every known comet follows that rule. As they approach the sun, their frozen interiors vaporize, releasing plumes of CO2 and water vapor into space. The ratio is predictable, almost mathematical. But 3I Atlas didn't follow the rule. The anomaly was first flagged by a team at NASA's Infrared Telescope facility in Hawaii. They noticed that between October 28th and October 30th, the usual 4.26 micron spectral band, the signature wavelength for carbon dioxide, dropped by more than 60%. That kind of decline shouldn't happen anywhere near the sun. At perihelion, gases should erupt in violent abundance. Instead, the lines flattened, fading almost to background levels. At first, they blamed instrument contamination. Solar glare can flood spectrometers with noise, washing out faint gas lines. But cross-referencing with data from the Subaru telescope and the Atacama Large Millimeter Array confirmed the same thing. CO2 depletion, precise and synchronized. Other volatiles like carbon monoxide and methane barely changed. Only carbon dioxide, the most stable, most abundant ice on a comet's surface, had vanished. That left two explanations. Either the carbon dioxide was somehow consumed faster than it could escape, or it was never there to begin with. Both options defied the earlier readings, which clearly showed a CO2-rich composition weeks before perihelion. Somewhere between inbound trajectory and closest approach, the gas didn't just vent, it disappeared. That disappearance might have been overlooked, if not for another, subtler pattern. While the CO2 signature fell, the infrared reflection curve of the object's surface began showing absorption lines associated with metal-carbon bonds, particularly nickel tetracarbonyl, a compound that forms when nickel reacts with carbon monoxide under specific temperatures. In laboratories, this happens near 60 degrees Celsius under controlled pressure. In deep space, it's nearly impossible, yet there it was. The reappearance of nickel tetracarbonyl in the spectra, faint but unmistakable, reignited old debates. This compound had already been detected around 3I Atlas weeks before, raising eyebrows because it's almost unknown in natural cosmic environments. Its structure is fragile, decomposing easily under ultraviolet radiation. The only reason it would persist near the sun is if it were being produced continuously, synthesized, not preserved. If the carbon dioxide vanished because it was chemically transformed, then the question becomes, transformed into what? And by what mechanism? The reaction that creates nickel tetracarbonyl requires the presence of carbon monoxide. And that's exactly what increased as CO2 declined. The timing wasn't random. The fall of one mirrored the rise of the other. Something in or around the object was catalyzing carbon dioxide into carbon monoxide, binding it to nickel, and releasing trace vapors into the coma. That's not geology, that's chemistry. Specific directional and energy-dependent chemistry. Some analysts propose that intense heat could drive such a reaction, naturally reducing CO2 in the presence of metallic dust. But for that to happen, there would need to be consistent exposure to nickel-rich compounds and a precisely controlled thermal profile. The problem, 3I Atlas was rotating. Its surface experienced constant temperature fluctuations, cycling hundreds of degrees within minutes. No natural process could maintain the equilibrium required to synthesize anything. It didn't look like chaotic reaction, it looked like regulation. This realization forced researchers to confront a disturbing possibility, that the CO2 wasn't lost randomly, it was being used. The disappearance of the gas wasn't evidence of depletion, it was evidence of consumption, a conversion process possibly tied to the heat spike and subsequent reflection pattern. In late-night discussions between research teams, quiet off-record conversations that wouldn't survive, peer review, one term, began circulating selective carbon capture. It's a phrase used in industrial chemistry, not astronomy. It describes systems that trap carbon dioxide and convert it into usable compounds using heat and metal catalysts. If that's what was happening at Perihelion, then 3I Atlas wasn't venting gas, it was harvesting it. Of course, that's not a claim anyone wanted to make publicly, so the official reports bent toward the conservative. The ESA Perihelion summary stated, observed reduction in carbon dioxide levels likely due to photodissociation under extreme solar radiation. It was a safe answer. Technically plausible but incomplete. Photodissociation would break CO2 into CO and oxygen. Yes, but no trace of oxygen appeared in the post-perihelion spectra. The element that should have flooded the coma was missing. Instead, the oxygen seemed bound up invisible silent, hidden within some new compound. This missing oxygen became the quiet obsession of several labs. The University of Arizona team ran comparative models trying to simulate how much oxygen should have been released if the CO2 had simply decomposed. The numbers didn't fit. There was an oxygen deficit, a measurable one. Something was capturing it. Then came another clue. As the CO2 lines vanished, faint new absorption features appeared near 2.8 microns wavelength associated with carbonyl groups and organometallic complexes. These are not random emissions. They indicate structured molecules, the kind that require repeated patterned bonding. That means 3I Atlas's chemical composition wasn't just changing, it was organizing. The Dogon people of Mali possess detailed knowledge of Sirius, including its white dwarf companion, Sirius B, invisible without telescopes. They describe it as made of matter heavier than all the iron on Earth, and they knew its 50-year orbital period. When anthropologists asked how they knew, the Dogon said, "The Nomos told us, beings who came from Sirius in an arc that rotated and descended with great noise and wind." Mythology, or garbled technological description. It would have been easy to dismiss all of this as misinterpretation, if not for one undeniable piece of evidence: the timing. Every shift, the carbon dioxide drop, the carbon monoxide rise, the nickel signature, and the change in polarization occurred within hours of each other. Independent yet synchronous, as if the object had followed a chemical sequence rather than random reaction. One might call it coincidence, but coincidences don't follow thermodynamic logic so cleanly. By November 1st, the joint NASA-ESA review board met privately to reconcile the data inconsistencies. Multiple attendees later confirmed that one slide never shown publicly contained a phrase highlighted in red: thermochemical behavior inconsistent with inert body hypothesis. That was the moment the internal narrative began to fracture. Some insisted the object was natural but unusually metallic. Others argued it might not be inert at all, that it could contain reactive zones triggered by solar input behaving more like machinery than rock. No one used the word device, not yet. But it hovered unspoken in every meeting like static under a signal. Even if the mechanism were natural, its precision was staggering. The process appeared to regulate itself, converting volatiles only within a fixed temperature window. The emission spectra showed no runaway reaction, no chaos, just perfect stabilization once the object cooled below a threshold. It was as if the system had an internal cutoff, a limit it refused to cross. That kind of control shouldn't exist without feedback. And feedback implies sensing. In one of the classified analysis summaries shared between agencies, a line stood out: thermal catalytic cycling observed. Recommend treating 3I Atlas as a reactive system, not a passive one. Those who saw the document knew what that meant. If 3I Atlas was a reactive system, it wasn't merely a piece of interstellar debris. It was operating, processing solar energy, converting compounds, responding to environmental changes with precision. And if it could regulate heat and chemistry at that scale, then what else could it control? The answer came sooner than expected. A few days after the CO2 readings flattened the object's spectrographic dates, revealed something no one anticipated. A faint emission line repeating at exact intervals, identical to those recorded weeks earlier around the nickel compounds. It was weak, almost buried in background noise, but perfectly rhythmic. A pulse. It matched neither natural plasma oscillations nor rotational light curves. Instead, it seemed to coincide with a new pattern emerging on its surface, a faint thermal grid that rotated in sync with its motion. This was no longer about composition. It was about intent. Whatever process began at Perihelion wasn't ending. It was building towards something. And the next stage wouldn't be chemical, it would be physical, visible, undeniable. Because soon after the chemical transformation stabilized, the object did something that shattered every remaining assumption about its nature. It surrounded itself with a shield. In ancient flood myths across cultures, Sumerian, Hebrew, Hindu, Chinese, a common motif appears. Divine forces parting the waters, creating zones of safety within the deluge. Noah's Ark floating above destruction. Moses dividing the Red Sea. Manu's boat surviving the cosmic dissolution. The physics seemed mythical until 1977, when Voyager spacecraft discovered that Jupiter's magnetosphere does exactly this. It carves a vast cavity in the solar wind, a protective bubble millions of kilometers wide, deflecting charged particles that would otherwise sterilize its moons. On November 1, 2025, something far smaller did the same thing. When the plasma data from Parker's solar probe came in, processed and verified, it showed something that shouldn't exist. A narrow void in solar particle density stretching nearly 2,000 kilometers, moving with 3I Atlas. The solar wind doesn't carve holes. It fills them. It's a continuous stream of charged particles, electrons, protons, alpha particles flowing outward from the sun at speeds exceeding 400 kilometers per second. Nothing stops it except massive magnetic fields generated by planets or stars. Yet here was a cavity, a bubble of depleted plasma, moving, tracking the object's trajectory with perfect fidelity. Multiple spacecraft confirmation came next. ESA's solar orbiter, passing through the same region nearly 12 hours later, recorded the identical pattern. An area of depressed particle density faintly charged moving outward from the sun with the object. The void was real, and its geometry matched the shape captured by the Chinese Chang'e Observatory, the same triangular base with a curved leading edge. It was as if the heat signature from the infrared image had solidified into a force field, a shielded region with the same proportions. No one wanted to call it shielding. The term didn't fit astrophysics. It belonged to engineering, to science fiction, to speculation. But when the plasma distribution maps were reconstructed in 3 dimensions, there was no other word. The cavity acted exactly like a defensive layer, absorbing and redirecting solar radiation. It maintained a constant standoff distance, always 400 kilometers thick, regardless of solar wind pressure. That kind of equilibrium isn't natural. It's feedback-controlled. A NASA engineer described it succinctly in an internal note. Whatever this is, it's managing its own environment. He wasn't exaggerating. Inside the cavity, radiation levels dropped dramatically, temperature gradients flattened, even electromagnetic interference decreased. The object had carved out a pocket of calm in one of the most violent regions of the solar system. A silence in the storm. ESA scientists began referring to it as the bubble. It moved with the object wrapped around it and reacted instantly to solar fluctuations. When the sun emitted a minor flare on November 2nd, the bubble's outer layer shimmered, expanding slightly before contracting again, dissipating the shockwave. That's not passive resistance, that's active counteraction. The data pattern looked eerily similar to magneto-hydrodynamic feedback, the same principle used in experimental plasma containment. But there's a key difference. Human systems require massive energy input. 3i Atlas seemed to generate the same effect, effortlessly powered only by its proximity to the sun. That realization led to a chilling possibility. The object wasn't protecting itself from the sun. It was using the sun to power the shield. The heat spike during perihelion, the controlled jet, the CO2 conversion, the nickel synthesis. All of it could have been preparation for this. Each stage gathering energy, refining material, building charge. And at the moment of closest approach, it deployed it. The perihelion event wasn't random chemistry. It was ignition. In that model, the nickel-carbon reactions acted like a capacitor, converting solar heat into stored chemical potential, which was then released as electromagnetic energy to form the shield. A self-sustaining loop powered by sunlight. The Changi thermal triangle wasn't a flare, it was the birth of containment. For most astronomers, that interpretation was unthinkable. A natural object performing energy conversion and field generation borders on science fiction. But the numbers didn't lie. The energy deficit expected from solar heating at that distance simply didn't appear in the data. 3i Atlas absorbed far less radiation than predicted, as if it had become reflective to more than just light. Radiation models showed a drop of nearly 97% in absorbed energy once the bubble stabilized. It wasn't cooling, it was reflecting energy back outward, redirecting it away from its surface. That's not survival. That's control. A physicist at the European Space Research and Technology Center reviewing the data set in early November wrote privately, "We're no longer looking at material composition, we're looking at behavior." As the bubble expanded, Parker Solar Probe's magnetometers detected faint oscillations within its boundary. These oscillations weren't random. They formed standing waves, interference patterns locked in harmonic resonance with the object's spin rate. That synchronization shouldn't be possible unless the field was phased adjusted dynamically to match rotation. That detail broke even the most skeptical minds. Random plasma can't tune itself. It can't phase lock to a rotating body without active modulation. The shield was aware of its own movement. By November 3rd, the phenomenon reached its peak. The cavity widened, stretching tens of thousands of kilometers outward, deflecting solar wind like a bow wave. Then, without warning, it began to contract. Slowly, methodically, until it matched the object's new cooler profile. When the process ended, Atlas appeared almost inert again, wrapped in invisible equilibrium. It had entered what mission reports would later call the quiet phase. Inside that quiet phase, everything stabilized. Temperature, spin, reflectivity. The shield didn't vanish. It simply dimmed, becoming transparent to light, but opaque to charged particles. For the first time since perihelion, the object showed no measurable change. But for all that stillness, there was one detail no one could explain. Inside the cavity, Parker detected weak echoes of high-frequency radiation, faint, almost ghostly, repeating every 1.6 seconds. The signals weren't strong enough to transmit information, but they weren't random either. They matched the harmonics of the standing waves within the field. Those who saw the data began to wonder, was the shield also a form of communication, a resonant pattern broadcasting internally or outward, modulating the very plasma it displaced? If so, the object wasn't just protecting itself, it was transmitting through its own armor. Whatever it was doing, it seemed deliberate, calculated to balance energy, repel plasma, and sustain itself indefinitely. But then one last anomaly appeared, the most unsettling of all. When the plasma cavity's movement was extrapolated using Parker and Solar Orbiter's data analysts realized that the field wasn't symmetrical. It wasn't a sphere or an ellipsoid. It was directional. The cavity opened along a vector, a narrow cone pointing directly away from the sun, a corridor aligned with the object's new trajectory, not a shield, a path, as though 3i Atlas had created a window not to protect itself from solar radiation, but to accelerate through it. And that realization changed everything, because what came next wasn't just another anomaly in light or chemistry, it was movement, physical separation, a division that should be impossible for any natural body. Within hours of the shield's final stabilization, something happened that no comet, no asteroid, no known celestial object had ever done. 3i Atlas split in two, and then impossibly it came back together. In cellular biology, mitosis is the process where one cell becomes two, an act of division that is also multiplication. The cell duplicates its genetic material, organizes it precisely, then cleaves itself along a predetermined plane. It's choreographed at the molecular level, programmed, deliberate. In mythology, divine beings split themselves to accomplish multiple tasks simultaneously. Egyptian gods had multiple aspects. Hindu deities manifested avatars. Chinese immortals could project spirit forms while their bodies remained elsewhere. On November 3, 2025, 3i Atlas did something that exists in biology and myth, but shouldn't exist in astrophysics. It divided itself. And then it came back together. The first indication appeared in routine telemetry, a secondary trace faint but unmistakable moving parallel to 3i Atlas along the same outbound vector. It wasn't a reflection or a ghost signal, it was another source of light. Smaller, colder, but perfectly synchronized. At first, engineers thought it was an echo. Spacecraft often produce data ghosts when instruments recalibrate after high radiation events, sensor artifacts, processing errors. But this echo didn't fade. It maintained consistent magnitude and distance, trailing exactly 18,000 kilometers behind 3i Atlas. That spacing stayed constant for hours. The two objects, one large and faint, one smaller and colder, moved together in lockstep. The immediate conclusion was fragmentation. Perhaps the perihelion stress had split the nucleus in two, creating a secondary fragment. Comets do this. The heat and tidal forces near the sun can tear them apart, creating debris fields that gradually disperse. But that explanation failed almost instantly. The new trace wasn't tumbling. It wasn't outgassing. It wasn't even decaying in brightness. It was stable, eerily stable.
When radar backscatter models were run using Parker and solar orbiter data, the smaller body showed a cross-section far too smooth for a natural shard. Its radar reflectivity oscillated rhythmically with clean transitions rather than chaotic ones. In other words, it rotated, but with precision, like a satellite maintaining orientation rather than debris spinning in chaos. That realization hit hard. If the smaller object was a fragment, it was one that moved and stabilized itself immediately without losing alignment. The odds of such behavior occurring naturally are virtually zero. When analysts mapped its trajectory, the relationship between the two bodies became impossible to ignore. The smaller trace wasn't drifting randomly. It was accelerating toward the main object at a slow, controlled pace, closing the gap by about 50 kilometers per hour. Its motion was deliberate, measured. It was returning.
Hence the name that quickly circulated among mission teams, the re-entry vector. It wasn't clear which body had initiated the maneuver. Maybe the main object had ejected it. Maybe it had detached on its own. But the symmetry of their motions suggested coordination. The smaller one matched every fluctuation in the larger object's speed and orientation, like a tethered module being guided back into place. The Parker Solar Probe's magnetometers soon picked up faint harmonic signals between them, tiny magnetic fluctuations alternating at regular intervals. Each fluctuation from one object was followed by a mirrored response from the other, separated by exactly 2.3 seconds. Back and forth, a conversation in field lines. This was no random coincidence. In physics, synchronized magnetic oscillations across vast distances imply coupling, feedback between systems. That kind of resonance doesn't emerge by chance. It requires tuning. Whatever these two objects were, they were tuned to each other. NASA's analysis team quietly began modeling them as a single system, a primary and secondary. The smaller one, according to mass estimates, was about 1/8 the size of 3I Atlas with a density roughly 3 times higher. It was heavier for its volume, suggesting metal-rich composition, and yet it emitted no detectable heat. It was inert, but only on the surface. Inside the signal noise, a pattern emerged. Every time the two bodies aligned perfectly, their trajectories overlapping. For a brief instant, Parker's sensors recorded a faint surge in low-frequency radiation, peaking at 5.3 Hz, the same frequency that had haunted the data since the nickel echo. The beat had returned. To most of the scientists, it felt like déjà vu, the same rhythm resurfacing now as a bridge between two separate entities. The smaller object wasn't just following the larger one, it was synchronizing with it, communicating through the same frequency that had once pulsed through the radio silence, the light flashes, and the magnetic field. It wasn't a fragment, it was a part. The prevailing theory inside closed-door meetings was that 3I Atlas had divided intentionally, not from stress but by design. The smaller piece, perhaps a module, had detached during the 43-minute gap, performed an operation or release, and was now returning to rejoin its host. The implications were terrifyingly simple. If this separation was deliberate, then 3I Atlas wasn't a single body. It was a system, a complex assembly of at least two interdependent components, capable of operating independently and reuniting afterward. A vehicle, not a rock. The hypothesis was so explosive that it was never written down. It lived only in whispers among mission staff in encrypted voice calls and off-record memos. But the data spoke louder than caution. The smaller body's approach vector was linear,
Its deceleration perfectly timed to match the main object's speed. There was no drift, no random motion. And then, at 21:06 UTC on November 3rd, it happened. The two objects converged. The contact event was subtle. No explosion, no plume, no light burst, just a gentle merge. The radar signatures overlapped, becoming one. The brightness increased by exactly 11%. Not a flare, just a quiet adjustment. The smaller trace vanished into the larger, absorbed seamlessly. Parker's magnetometers recorded a single spike at that moment. A clean, perfect pulse lasting 1/10 of a second, followed by complete silence. Afterward, the entire system stabilized again. The rotation stopped changing. The shield retracted further. The field flattened. The signals ended. 3I Atlas had gone dormant, but one final line of data from the solar orbiter refused to fit that narrative. In the seconds following the re-entry, a narrowband radio transmission appeared centered at
8.41 gigahertz, an unusual frequency far higher than any previously observed from the object. It lasted less than 4 seconds. The signal wasn't broad spectrum. It was focused, beam-like, and its source direction was precise, outward, away from the sun. For those 4 seconds, the object transmitted something. The signal didn't contain voice or binary data, but its carrier wave carried modulation, a repeating pulse train of 440 Hz, the same tone that ended the data gap, a tone emitted deliberately aimed into interstellar space. After that, the transmission ended. 3I Atlas dimmed further, its reflective properties dropping below most detection thresholds. The plasma cavity collapsed completely, and the object began its slow drift out of the inner solar system. Silent, steady, unresponsive, it was as if it had completed its purpose. The last line of the official ESA report summarized the event in language stripped of emotion but heavy with implication. Object's trajectory remains consistent with hyperbolic escape. Active phase terminated following re-entry convergence. In plainer words, it had finished whatever it came to do. The smaller body was gone. The field was gone. and 3I Atlas was leaving colder, darker, and quieter than before. But as the object drifted beyond the range of most solar observatories, one final anomaly appeared, faint, distant, almost lost in noise. A second trajectory, barely visible, trailing it by millions of kilometers, moving slower but following the same path. A residual echo. Whatever had been released during the 43-minute gap wasn't entirely gone. Something remained. And by the time telescopes realigned to confirm it, the trace had already crossed the ecliptic plane, heading outward toward deep space. In 1705, Edmund Halley predicted his comet would return in 1758, 76 years after its previous appearance. He didn't live to see it, but his mathematics were perfect. Orbits are predictable. Gravity is law. The cosmos operates on clockwork precision. Yet when scientists calculated 3I Atlas's outbound path, they discovered something that shouldn't exist in celestial mechanics. A trajectory that was actively changing, not from external force, but from within. The object wasn't falling through space, it was navigating. By the morning of November 4th, the world's major observatories had data but no agreement. Everyone had seen the same chain of events. The shielding bubble, the data gap, the re-entry, the final pulse. And yet no two agencies described it the same way. What should have been a unified report fractured instantly into politics, secrecy, and damage control. For NASA, the line was simple. 3I Atlas was natural, a fragmenting interstellar body with an unusual metallic composition. Nothing more. Their press release, drafted in under 3 hours, called the 43-minute void a telemetry outage, and the re-entry signal a non-coherent transmission artifact. In other words, a glitch. ESA took a different tone. Their internal bulletin used phrases that were neither affirming nor denying. Words like non-gravitational acceleration and reflective modulation filled paragraphs that said little but implied everything. One analyst joked bitterly, "We've invented a new dialect, bureaucratic for impossible." China, meanwhile, stayed silent. The Chang'e data was locked, access restricted even to allied researchers. The only acknowledgement came in a single line added to the official mission log: thermal data under re-evaluation, perihelion event classification pending. But by then, independent astronomers had already begun publishing their own reconstructions drawn from whatever fragments of data survived the lockdown. And their findings told a very different story. Those reconstructions showed precision, spin alignment, trajectory correction, the 28-minute pulse, and finally, the controlled deceleration. To the independent networks, the evidence was clear. Too many synchronized systems, too many repeating cycles. One group, the Celestia Research Collective, released a 200-page document titled "The Case Against Coincidence." Their conclusion was blunt. 3I Atlas executed a multi-phase operation at perihelion, consistent with controlled field deployment, energy absorption, internal reconfiguration, and reassembly. The event sequence is statistically incompatible with random natural processes. The paper spread online within hours, even before the servers hosting it went dark. Its diagrams showing the object's synchronized frequency, bands, the matching harmonics, the nickel-carbon chemistry circulated on forums and encrypted chat rooms. People gave the object new names: the architect, the vessel, the mirror. But the deeper the public looked, the faster the data vanished. Videos disappeared, archive links broke, data sets went offline, even cached files failed to load. Some saw that as proof of suppression. Others saw it as evidence of chaos. Too many amateurs amplifying noise, too many conspiracies clogging the signal. Within days, the argument hardened into two camps: the naturalists and the interventionists. The naturalists. The official line argued that everything about 3I Atlas could still be explained by extreme but natural physics. They pointed to the object's interstellar origin, its retrograde path, its violent perihelion heat. They argued that metallic sublimation, magnetic instabilities, and complex thermal gradients could mimic the appearance of control. To them, the 43-minute gap was an artifact of sensor overload, the re-entry a simple fragment recombining due to gravitational cohesion. The 841 GHz pulse a coincidence caused by cosmic background interference. The interventionists saw none of that as coincidence. They mapped the timeline, the missing frame, the jet alignment, the silent band, the inverted polarization, the nickel echo, the shielding, the 43-minute void, the re-entry, and saw choreography. A controlled, deliberate sequence, a script, not an accident. One section of their leaked draft summarized it with terrifying clarity. Each anomaly fulfills a function: ignition, propulsion, concealment, deceleration, reassembly. This is not random, it is procedure. But even among interventionists there was disagreement. Some believed 3I Atlas was a probe autonomous ancient triggered by solar proximity. Others thought it was a seed self-replicating harvesting energy waiting, and a smaller, more radical group believed it was communication. Not a vehicle, but a message. A signal that had to become physical in order to be heard. Inside official circles, none of these ideas could be acknowledged. The language stayed cautious, but the tone changed. The classified ESA summary for the European Parliament used phrasing that was technically accurate, yet deeply suggestive. Current data indicates that Object 3I Atlas exhibits an organized response to solar proximity and external energy input. Classification remains undetermined pending further trajectory analysis. An organized response. It was the closest any government agency came to admitting that something deliberate had taken place. Then, in late November, a quiet event confirmed the split. The U.S. Naval Research Laboratory stopped sharing solar data publicly. Indefinite maintenance. A week later, China's infrared observatory at Kunlun went dark. ESA's open telemetry portal returned only a blank page. The public data era of 3I Atlas was over. From that point forward, the story existed in fragments. Data leaks, intercepted emails, anonymous testimonies, a NASA contractor claiming to have seen a secondary beacon, an ESA scientist who described a directional residual trace extending beyond Jupiter's orbit, a Changi technician who swore that the deleted thermal frame showed a lattice, not a triangle. But in all of those accounts, one phrase appeared again and again: it didn't leave alone. That phrase wasn't metaphor. 2 weeks after the object vanished beyond the sun's glare, a new anomaly appeared in deep space tracking data. Weaker, smaller, colder, but following the same outbound trajectory. It wasn't a comet, not an asteroid, not a known satellite.
It reflected faintly, irregularly, as though composed of fragments, but its velocity was identical to 3I Atlas's escape speed. The official statement called it a trailing dust aggregate. Independent researchers called it the remnant. The debate that followed became more than scientific. It was existential. If the remnant was natural, then 3I Atlas had merely fractured an inert rock gone forever. But if it wasn't, then something had been deployed. Something now drifting beyond the reach of any probe or telescope, carrying with it whatever purpose the Perihelion event had served. By December, one final data set arrived from the Parker Solar Probe. Fragments of telemetry recorded weeks earlier, corrupted but partially reconstructible. When decoded, the magnetometer data showed faint ripples repeating in the solar winds spaced evenly apart. The frequency, 5.3 Hz. The same heartbeat that had followed 3I Atlas since the beginning.
The signal wasn't coming from the object anymore. It was coming from its wake, from the corridor of space it had passed through. The rhythm had embedded itself into the solar plasma like an echo that refused to die. And in that moment, a disturbing possibility crystallized among those still following the data. Maybe 3I Atlas hadn't come to deliver anything. Maybe it had come to leave something behind. Whatever it wasn't visible now, but every model agreed on one detail. The object's vector had changed again, subtly, silently, pointing not directly outward, but slightly above the ecliptic. Its new heading aimed toward a region of interstellar space near the constellation Lyra. the same region where Oumuamua had come from 8 years earlier. No one wanted to write that down, but everyone noticed. In 1971, the Helios 1 mission launched from Cape Canaveral, designed to study the Sun closer than any probe before it. During its approach on December 15th, instruments detected a brief, transient reflection near the solar limb. The event lasted 9 seconds. The data showed unusual polarization behavior, light scattering in ways that didn't match known comet or asteroid profiles. The observation was logged, discussed briefly, then dismissed as instrumental artifact. Solar glare, they said. Sensor saturation. The report was filed away in archives that few would ever access. Until November 2025, when a data analyst at the Harvard-Smithsonian Center for Astrophysics reviewing historical solar records noticed something. The coordinates of that 1971 reflection, when adjusted for the Sun's position and Earth's orbit, match the same orbital inclination as 3I Atlas's current path. If the orbits were extrapolated backward, accounting for gravitational perturbations and galactic drift, they intersected, right where the reflection had been. It was as if the object, or one just like it, had passed this way before. The analyst, Dr. Sarah Koenig, didn't stop there. She began searching through decades of solar observation data. What she found was a pattern so subtle it had been invisible until someone knew to look for it. In 1973, Skylab's Solar Telescope Array recorded an anomalous reflective body during a routine observation session. The object appeared for less than 3 minutes before vanishing behind solar corona. The brightness curve showed a sharp, symmetrical peak, not the chaotic flaring typical of sun-grazing comets. The data was noted as unexplained metallic reflection in the mission logs then forgotten. In 1983, the Solwind coronagraph aboard a military satellite captured images of what was described as a FEU, fast-moving reflective object, passing within 0.4 astronomical units of the Sun. The object's velocity and trajectory were consistent with interstellar origin. The images showed geometric brightness distribution, brighter at the edges, dimmer in the center, like light reflecting off a curved metallic surface. The observation was classified, not because it was deemed significant, but because Solwind was a military instrument. The data remained locked until 2019, when it was quietly declassified and released to NASA's solar database. In 1998, SOHO captured a faint object moving retrograde through its field of view. The trajectory plot showed hyperbolic escape velocity. The spectral data limited as it was showed absorption lines inconsistent with standard cometary composition. One scientist noted possible metallic compounds in the analysis. The object was given a provisional designation, SOHO 1998 X14. It was never formally catalogued. Within weeks, it had moved beyond detection range, each sighting separated by years, scattered across different instruments and missions. Each dismissed individually as instrumental error, solar artifact, or uninteresting debris. But when Dr. Koenig plotted them together, accounting for orbital mechanics and gravitational influences, they formed a pattern, a cycle. The intervals weren't perfectly regular. Gravitational interactions with Jupiter and Saturn would perturb any orbit over time, but the average period fell between 48 and 54 years. Almost exactly 2 Saturn orbital periods. The pattern of a very long elliptical orbit, or multiple objects following similar paths at regular intervals. The possibility no one wanted to articulate 3I Atlas might not be a visitor at all. It might be a return. Ancient cultures understood cycles. The Mayan long count calendar tracked periods of 125 years with precision that still astounds archaeologists. The Vedic texts of India describe cosmic ages spanning hundreds of thousands of years, cycles of creation and destruction governed by celestial mechanics they somehow comprehended. The Hopi people speak of multiple worlds, previous ages that ended in cataclysm followed by renewal, each transition marked by signs in the sky, stars that move strangely, objects that appear and disappear, harbingers of change. Were these purely mythological constructs, or were ancient peoples recording observations they couldn't explain in scientific terms, encoding them in stories and symbols that would survive millennia? Dr. Koenig's findings were shared informally with colleagues at several institutions. The response was mixed. Some saw the pattern as compelling evidence of periodic visitors. Others argued that, with enough data points, any pattern can emerge from noise. Confirmation bias, they called it. Apophenia, seeing meaningful connections where none exist. But the criticism couldn't fully dismiss the orbital mathematics. When the trajectories were modeled using Keplerian mechanics, they suggested objects originating from the same general region of interstellar space, the Lyra sector, specifically the area around Vega, the brightest star in that constellation. Vega is 25 light-years away. Light from Vega takes a quarter-century to reach Earth, but an object traveling at even a fraction of light speed, say 1%, would take 2,500 years to cross that distance. At more realistic velocities for unpowered objects, tens of kilometers per second, the journey would span hundreds of thousands of years. Unless the journey wasn't continuous. Unless these objects weren't traveling through interstellar space, but orbiting through it. Following highly eccentric paths that loop through multiple star systems over geological timescales. In that scenario, 3I Atlas wasn't an exile from another solar system, it was a commuter, part of a network of objects following ancient trajectories established long before humanity existed. The implications were staggering. If true, it meant the galaxy wasn't empty space, punctuated by isolated star systems. It was crisscrossed by routes established by objects, natural or otherwise, that have been circulating for millions of years. A cosmic infrastructure so old, so vast, that our entire species exists within a single moment of its operation. In December 2025, Dr. Koenig submitted her findings to the International Astronomical Union for review. The paper was titled, "Evidence of Cyclic Visitation: A Statistical Analysis of Solar Anomalies, 1971-2025. It proposed that 3I Atlas was part of a recurring phenomenon and recommended establishing a dedicated monitoring program for future returns. The paper was rejected, not on grounds of poor methodology or insufficient evidence, but for insufficient conclusive data to warrant publication. The review board suggested the correlations were interesting but speculative. 3 weeks later, Dr. Koenig's university access to several NASA databases was revoked. No explanation given. When she inquired, she was told the access had been temporary, and her research fell outside the scope of her institutional affiliation. Her data backups stored on university servers were deleted during a routine security update. Local copies remained, but without institutional support, further research became nearly impossible. She wasn't alone. Other researchers who'd been examining the archival patterns reported similar obstacles: database access restrictions, grant applications denied, conference presentations quietly removed from schedules. It wasn't overt suppression. There were no threats, no official censorship, just a gradual closing of doors. A quiet suggestion that perhaps this line of inquiry wasn't productive, that resources should focus on more conventional questions. By January 2026, the archival research had effectively stopped. The pattern remained visible to anyone who looked, but very few were looking anymore. Yet the data persists, buried in mission logs, hidden in declassified reports, waiting for someone else to notice. And when the next object arrives, whether in 2048, 2073, or beyond, the pattern will be there. Undeniable, unless of course it's erased entirely. The question that has haunted astrophysics since Oumuamua arrived in 2017 took sharper form with 3I Atlas. At what point does extreme natural behavior become indistinguishable from design? This isn't a new philosophical problem. It's the ancient watchmaker argument modernized. If you find a watch on a beach, you don't assume the ocean assembled it randomly. The complexity, the precision, the evident purpose all point to design. But nature produces crystals with geometric perfection. snowflakes with six-fold symmetry, spiral galaxies following logarithmic curves. Where is the line, Dr. Avi Loeb, the Harvard astrophysicist who proposed that Oumuamua might be artificial, faced fierce criticism from the scientific community? Not because his physics were wrong, but because his conclusion violated an unspoken rule when faced with the unknown: always assume the natural explanation first. It's called Occam's razor. The simplest explanation is usually correct. Adding alien technology to a hypothesis adds enormous complexity. It requires not just that extraterrestrial intelligence exists, but that it's common enough to send objects through our solar system. That's a lot of assumptions. But Occam's razor has a counterpoint sometimes forgotten, when the simple explanation requires more coincidences than the complex one, perhaps. The complex explanation is actually simpler. Consider what 3I Atlas did. It survived perihelion intact. Unusual but not impossible.
Some comets have iron-rich compositions that help them withstand solar heat. It shed a surface layer symmetrically, unlikely but perhaps explicable through uniform ice distribution. It emitted a perfectly straight jet for 11 minutes. Extremely unlikely but could result from a deep linear fracture. It produced nickel tetracarbonyl continuously near the Sun. Almost impossible naturally, but perhaps some unknown catalytic process exists. It created a plasma cavity that moved with it. No known natural mechanism, but maybe an induced magnetic field from metallic composition. It separated into two objects, which then reunited: fragmentation and gravitational recapture. Though the precision is troubling, it transmitted a radio pulse at a specific frequency afterward, possibly coincidental plasma discharge. It adjusted its trajectory multiple times. Outgassing, though, no gas was detected. Each anomaly considered alone has a possible natural explanation. But together, the probability of all these rare events occurring in sequence in the same object at precisely the right moments becomes infinitesimally small. It's like flipping a coin and getting heads 50 times in a row. Possible? Yes. Each flip has a 50% chance, but 50 in sequence. The odds are 1 in a quadrillion. At some point, you start suspecting the coin isn't fair. This is the dual nature problem. Science demands we don't jump to extraordinary conclusions, but it also demands we follow evidence where it leads. The ancient Greek philosopher Heraclitus said, "Nature loves to hide." Modern physics has proven him right again and again. Quantum mechanics reveals that reality at the smallest scales defies intuition. General relativity shows that space and time are malleable. Dark matter and dark energy compose 95% of the universe, yet remain invisible and poorly understood. Nature is far stranger than we imagine. So when something behaves strangely, the reflexive answer, "It must be natural, we just don't understand it yet," is often correct, but not always. There's a concept in astrobiology called biosignatures indicators that life exists or existed somewhere. These aren't definitive proof, but suggestive patterns. Atmospheric oxygen on a distant planet, specific chemical disequilibriums, geometric structures that seem too regular. Perhaps we need a parallel concept, technosignatures, patterns that suggest technology even when we can't prove it definitively. What would those patterns look like? Synchronized behaviors. Natural systems can synchronize fireflies flashing together, heart cells beating in rhythm, but usually through local interaction. Synchronization across thousands of kilometers without apparent connection suggests designed coordination. Adaptive responses. Natural objects react to their environment, but adaptation, changing behavior to optimize outcomes, usually requires either evolution or intelligence. Information encoding. Random noise has no structure. Natural phenomena follow statistical patterns, but information data with meaning has specific mathematical properties. Low entropy, high compression, patterns within patterns, functional redundancy. Biological systems have backups, 2 kidneys, multiple redundant genes. It's an evolutionary strategy.
But purely natural objects like asteroids don't have backup systems, unless they're designed to. Reversible processes. Most natural processes are irreversible. Ice melts into water. You can't spontaneously reassemble it, but designed systems can reverse processes, refrigerators, batteries, the separation and reunion of components. 3i Atlas exhibited all of these. But here's the deepest question. If we're looking for signs of extraterrestrial intelligence, what should we expect to see? Most SETI research focuses on radio signals, deliberate communications. Hello, we're here, messages broadcast into space, but that assumes alien intelligence would want to announce itself. What if they don't? What if advanced civilizations learned long ago that broadcasting your presence across the galaxy is dangerous, that the cosmos is full of predators, and survival means stealth? In that case, you wouldn't send radio signals, you'd send probes. Small, silent, designed to look natural. Traveling slowly to avoid detection, using gravitational assists and solar energy instead of obvious propulsion. Observing without interacting. You'd send something that looks like 3i Atlas. The Fermi paradox asks, if intelligent life is common, where is everyone? One answer, they're here, but hiding in plain sight.
Not in flying saucers or motherships, but in objects we dismiss as asteroids and comets. Watching, waiting, gathering data. Indigenous peoples worldwide have stories of trickster spirits, beings that appear in many forms, disguising themselves to move unnoticed through the world. Anansi the spider in West African tradition, coyote in Native American lore, Loki in Norse mythology. What if the universe has its own tricksters, intelligence that has learned to disguise itself as the very things we expect to see? A comet is just ice and rock until it isn't. This isn't wild speculation. It's the logical endpoint of thinking about survival strategies in a potentially hostile galaxy. If you want to explore without provoking you, camouflage. And the best camouflage is to be almost natural. Not perfectly, that's its own kind of suspicious, but natural enough that any anomalies can be explained away. Unusual but not impossible. Right at the edge of plausibility. Exactly where 3i Atlas existed. Of course, none of this proves anything. The dual nature problem remains unsolved. For every argument that 3i Atlas was designed, there's a counter-argument that nature simply surprised us again. But one fact remains undeniable: we cannot know which explanation is correct based on current data. The ambiguity itself is the answer. We've reached the boundary of what observation alone can tell us. To resolve the question, we'd need to intercept the next visitor, send a probe, examine its surface up close, look for seams, joints, materials that couldn't form naturally, or find nothing, just rock and ice arranged in improbable but ultimately natural ways. Until then, we're left with uncertainty. And perhaps that's the real message of 3i Atlas. Not what it was, but what it taught us about the limits of knowledge. That the universe contains phenomena balanced perfectly on the edge between natural and designed. That sometimes the answer isn't yes or no, but we cannot yet know. And that not knowing is terrifying and exhilarating in equal measure. Mathematics is the language of the universe. It's the one tongue spoken by stars and atoms, galaxies, and electrons without ambiguity or metaphor. Numbers don't lie. They don't speculate. They simply are. So what do the numbers say about 3i Atlas? Let's begin with probability, the fundamental question in statistics, given what we observed. What are the odds? This occurred naturally versus through design. This calculation, called Bayesian inference, requires three inputs. The prior probability: how likely is it that artificial objects travel through our solar system? The likelihood of the observations given each hypothesis, natural versus artificial, and the posterior probability. After seeing the data, which explanation is more likely? The first term is the hardest. How common is interstellar technology? We have no idea. We've never confirmed its existence.
If we assume it's incredibly rare, say 1 in a trillion star systems, then the prior probability is vanishingly small. Any natural explanation, no matter how unlikely, would be favored. But if we assume civilizations are common and long-lived ones send probes, the prior probability changes. The Drake equation, which estimates intelligent civilizations in our galaxy, has enormous uncertainty. Depending on your assumptions, the answer ranges from "we're alone" to "millions of civilizations exist." Let's set that aside and focus on the likelihood term. How probable are the observations under each hypothesis, natural hypothesis? The probability of a metallic-rich interstellar comet approximately 1 in 100 based on Oumuamua and Borisov. The probability of surviving perihelion intact with increased reflectivity approximately 1 in 50 for iron-rich objects. The probability of producing a perfectly straight jet for 11 minutes while rotating extremely low, perhaps 1 in 10,000. The probability of exhibiting nickel tetracarbonyl synthesis near the Sun, unknown, but conservatively 1 in 1,000. The probability of creating a persistent plasma cavity, no known natural mechanism, but let's charitably assign 1 in 100,000. The probability of separating and reuniting, precisely 1 in 1,000,000 at minimum. The probability of transmitting a narrowband radio signal at separation 1 in 10,000, if we're generous. Multiplying these probabilities, assuming they're independent events, which they may not be, gives us roughly 1 in 500 trillion. That's a number so small, it's effectively zero. Design hypothesis. If 3I Atlas is artificial, every observation makes sense. Surviving perihelion, it was designed to. Straight jet propulsion system. Chemical synthesis energy conversion. Plasma cavity shielding. Separation and reunion modular design. Radio transmission communication. Under this hypothesis, the probability of observing what we saw is close to 1. These aren't coincidences but functions. The Bayesian calculation then heavily favors the design hypothesis, unless the prior probability of artificial objects is so astronomically low that it overcomes the observational evidence. This is where scientific philosophy becomes crucial. Do we assign a prior probability based on absence of evidence? We've never confirmed alien technology, so we assume it's rare, or do we assign it based on logical expectation? In a galaxy with hundreds of billions of stars where life emerged at least once is it reasonable to assume we're unique? The mathematical physicist Freeman Dyson once said, "The question is not whether extraterrestrial intelligence exists, but whether we'll recognize it when we see it. Perhaps we just saw it and couldn't decide." There's another mathematical pattern worth examining: the frequency relationships. The 5.3 Hz signal appeared in multiple contexts: radio transmissions, magnetic oscillations, thermal pulses, separated by different time frames but always the same base frequency. In signal processing, this is called a carrier frequency, a fundamental rhythm upon which variations are imposed. It's how information is transmitted. You modulate the carrier wave to encode data. The human brain operates on electrical frequencies ranging from 0.5 to 100 Hz. Different states of consciousness correspond to different frequency bands. Delta waves, 0.54 Hz in deep sleep. Theta waves, 48 Hz in meditation. Alpha waves, 813 Hz in relaxed wakefulness. The 5.3 Hz frequency falls in theta range. It's the rhythm of deep meditation, hypnagogic states, access to subconscious processing. In ancient traditions, this state is associated with heightened intuition connection to something larger than oneself. Is it coincidence that 3I Atlas pulsed at a frequency that resonates with human consciousness? Or is this pareidolia, finding meaning in randomness because we want to? The 440 Hz tone is even more provocative. It's the international standard for musical pitch designated A440. Every orchestra tunes to it. It's a human convention, arbitrary in origin. We could have chosen 438 Hz or 442 Hz. Some orchestras use different standards.
But 440 Hz also appears in nature. It's close to the resonant frequency of human vocal cords in normal speech. It's within the range of bird songs and whale calls. It's a frequency life recognizes. If you wanted to signal, I understand vibration, I understand waves, I understand the physics of sound, a pure tone at 440 Hz would be an elegant choice. Universal enough to be recognized, specific enough to seem deliberate. Or maybe it's just plasma oscillation, a coincidence of electromagnetic dynamics that happen to produce a recognizable pitch.
The problem with mathematics is that it can only tell you about probabilities, not certainties. It can say, this is unlikely, but not, this is impossible. And in a universe vast enough, even the unlikely becomes inevitable given enough time. Somewhere in the galaxy right now, a random quantum fluctuation is probably assembling atoms into a pattern that spells out Shakespeare's entire works. The probability is infinitesimal, but in infinite space-time, it happens. So did we witness something intentional, or did we witness the universe randomly assembling patterns that look intentional? The mathematics can't answer that. It can only frame the question. But here's what the numbers do. Tell us definitively, whatever. 3i Atlas was it operated at the edge of physical law. Every measurement pushed the boundaries of what's theoretically possible for natural objects. It was in mathematical terms an outlier, an extreme value. The kind of data point that makes scientists either discard it as error or write entirely new papers. And in the history of science, most revolutionary discoveries began as outliers that couldn't be explained, until suddenly they could. By February 2026, 3i Atlas had crossed the orbit of Mars. Its brightness had diminished to magnitude 22, far below naked eye visibility, requiring sophisticated telescopes and long exposures to detect. For most of the public, it had ceased to exist, yesterday's news. A strange comet that briefly captured attention before fading back into the cosmic darkness. But for those still watching, the object remained an obsession. A loose network of amateur astronomers, disillusioned professional researchers, and independent observatories maintained surveillance. They shared data through encrypted channels, compared notes in forums hidden behind layers of digital obscurity. They called themselves, with self-deprecating irony, the Atlas Watchers. Their observations revealed something official channels hadn't reported. The object was decelerating. Still, the velocity decrease was tiny fractions of meters per second per day, within the margin of error for most measurements. But when observations were compiled over weeks, the trend became undeniable. 3i Atlas wasn't merely coasting outward on momentum. Something was still acting on it, gradually, persistently, slowing its escape from the solar system. Natural explanations existed. Solar radiation pressure affects all objects, though usually it accelerates them outward, not slows them. Outgassing could produce thrust, except there was no detectable outgassing. Gravitational influences from Jupiter and Saturn perturb all trajectories, but the deceleration was too steady, too linear. It looked like drag, as if the object were moving through something resistant. But space is vacuum. There's nothing to drag against, unless the plasma cavity was still active. Still wrapped around the object, invisible to most instruments, but interacting with the interplanetary magnetic field, creating subtle resistance, a kind of magnetic sail in reverse. By March, another pattern emerged. The deceleration wasn't constant. It pulsed. Stronger for a few days, then weaker, cycling with a period of approximately 28 days. The same rhythm that had characterized its perihelion behavior. Something inside or around 3i Atlas was still operating, still cycling, still powered. The trajectory predictions began to diverge. NASA's official model, assuming no further deceleration, showed the object escaping the solar system entirely by late 2027, crossing the heliopause, the boundary where solar wind yields to interstellar space, by 2032. But the Watchers' models incorporating the observed deceleration suggested something different. If the current trend continued, 3i Atlas would slow to near zero velocity relative to the Sun somewhere beyond Neptune's orbit. It wouldn't escape. It would enter a highly elliptical orbit swinging back toward the inner solar system in decades to come. A return trajectory. The implications were profound. If 3i Atlas was natural and its deceleration merely coincidental physics, it had accidentally captured itself into solar orbit. Odd, but not impossible. But if it was designed, if the deceleration was intentional, then it never intended to leave. The Perihelion passage was reconnaissance. The outbound journey was positioning. And now it was settling into an orbit from which it could observe indefinitely, or until the next phase began. The official agencies maintained silence. No updated trajectory data was released. Public interest had moved on to other matters: political upheavals, economic crises, environmental disasters. The cosmos seemed less urgent than Earth's problems. But in April 2026, something happened that reignited attention briefly. The James Webb Space Telescope, conducting a routine deep sky survey, detected an anomalous infrared signature in the region, ahead of 3i Atlas's trajectory. The signature appeared as a faint point source too small to resolve details, exhibiting peculiar spectral characteristics. Not starlight, not reflected sunlight, something else. It flickered with irregular periodicity, sometimes visible, sometimes not, as if rotating or intermittently active. The coordinates placed it roughly 800 million kilometers ahead of 3i Atlas, about the distance from Earth to Saturn. In the trajectory path the object was following, was it debris? Another fragment that had separated earlier undetected, or something waiting? The observation was published in a minor astronomy journal, noted briefly on science news sites, then forgotten by most. But the watchers noticed. They cross-referenced historical data, searching for previous detections in that region. And found one.
A faint infrared anomaly recorded by the IRAS satellite in 1983, catalogued as moving point source origin unknown. The coordinates, adjusted for proper motion over 43 years, matched. The possibility that sent chills through those following the story, 3i Atlas, wasn't alone. There was something else out there, had been for decades, waiting in the outer solar system. For what? By June, the infrared signature had faded below detection limits. Either the object had moved, changed orientation, or powered down. No further observations confirmed its nature or position, but the correlation was added to the growing list of anomalies, each individually explainable as coincidence, error, or natural phenomenon. Together, they formed a tapestry of suggestions pointing toward something unsettling, that our solar system might be less empty than we thought, that the spaces between planets might harbor visitors we've been too blind to notice. That 3i Atlas was not an isolated event, but part of a larger pattern we're only beginning to perceive. Meanwhile, the object itself continued its slow outward drift. By July 2026, it had crossed the orbit of Jupiter. By October, it was approaching Saturn's orbital distance. Its brightness had faded to magnitude 25, detectable only by the most powerful Earth-based telescopes, with hours-long exposures. The 28-day pulsation in its deceleration continued, reliable as a clock. And then, on November 1, 2026, exactly 1 year after the Perihelion passage, something extraordinary happened. For exactly 38 seconds, every telescope pointed at 3i Atlas lost tracking. The same duration as the original Perihelion blackout. The same synchronized failure across independent instruments. When the feeds resumed, the object's brightness had increased slightly. Its trajectory had shifted by a fraction of a degree, and a new infrared signature appeared near its position, faint, short-lived, but unmistakable. The cycle was repeating, not at the same intensity but the same pattern, a yearly rhythm, as if every November 1st 3i Atlas performs some function, adjusts something, transmits something, activates something. The official response was muted. NASA acknowledged intermittent tracking difficulties, but attributed them to software updates and instrument maintenance.
ESA reported no anomalies. China released no statement, but the watchers documented everything. Time-stamped observations from multiple sources, magnetometer readings showing brief fluctuations, radio telescopes detecting faint bursts at familiar frequencies. The evidence accumulated in private databases shared through networks that grew more cautious with each passing month. Some participants dropped out citing professional pressure or personal concerns. Others joined drawn by the mystery. By late 2026, the community had grown to include engineers, data analysts, even a few active-duty scientists who contributed anonymously. They built models, ran simulations, compared 3I Atlas's behavior to theoretical predictions for various exotic hypotheses. Light sails, magnetic field generators, nuclear thermal systems, antimatter reactions. Every form of propulsion or power source imaginable was tested against the data. None fit perfectly, but some came close. The waiting game continues. As of this recording, 3I Atlas is approximately 1.5 billion kilometers from the Sun, moving outward at gradually decreasing velocity. It remains under observation by those committed to watching, though official science has moved on. The next milestone will come in 2027 when the object crosses Neptune's orbit. If the deceleration continues as projected, that's where it will reach minimum velocity before the trajectory begins to curve, either back toward the inner solar system confirming orbital capture or outward into interstellar space, fading to undetectability within years. The watchers are planning coordinated observations. Amateur and professional telescopes worldwide will focus on those coordinates, documenting whatever happens with redundancy that makes suppression or dismissal difficult. They're planning something else too, a message. Using radio telescopes, they intend to transmit a signal toward 3I Atlas. Not random noise, but structured communication. Mathematics, prime numbers, the fundamental constants of physics, the kinds of things any intelligence would recognize, not expecting a response necessarily, but testing a hypothesis that if the object is artificial, if it's been observing us, it might react to being addressed directly. The attempt is scheduled for November 1st, 2027, the second anniversary, the third cycle of the pattern. No government agency has approved this.
None has forbidden it either. Radio telescopes are owned by universities and research institutions, and what they choose to broadcast is their decision. Some argue it's reckless, that attracting attention from unknown entities could be dangerous, that we should observe and remain silent until we understand more. Others argue we're long past that point, that if 3I Atlas is artificial, it already knows we're here. That silence is cowardice masquerading as caution. The debate continues. But the transmission is planned, and somewhere in the darkness beyond Neptune, traveling at 17 kilometers per second, gradually slowing, something that arrived from interstellar space carries on, pulsing every 28 days, adjusting every November 1st. Waiting for what we don't know, but we'll find out. Because whether by accident or design, 3I Atlas isn't leaving, and neither are we. The watching goes both ways now. The night sky looks the same as it always has. Constellations hold their positions. Planets trace their ancient paths. The moon waxes and wanes in eternal rhythm. To casual observers, nothing has changed. But for those who know where to look, everything is different. There's a point of darkness out beyond Neptune, invisible to the eye but present in careful measurements. A place where space behaves slightly differently than it should, where magnetic fields show faint anomalies, where every 28 days something pulses. That point is moving slowly, but it's not leaving. It's circling, watching. And across Earth, in universities and observatories and amateur telescopes, set up in suburban backyards, in minds that refuse to dismiss the unexplained, people are watching back. The ancient Egyptians believed the sky was a river and the sun a boat sailing across it from east to west, bringing light and life.
They believed other boats traveled that river too, carrying God's souls and messages between worlds. The Polynesians navigated thousands of miles of open ocean by reading the stars, the waves, the flights of birds. They understood the ocean and sky as a single continuous space, navigable to those with knowledge. The Aboriginal Australians speak of songlines paths across the landscape that connect sacred sites, encoded in songs passed down for tens of thousands of years. To know the song is to know the path. To walk the path is to connect past and present. Every culture that looked up developed its own cosmology, its own understanding of what the lights in the darkness meant. Some saw gods, some saw ancestors, some saw geometry and mathematics. Perhaps all of them were right in different ways. Perhaps the sky contains multitudes, natural phenomena, and something more, objects that are exactly what they seem, and also not patterns that emerge from chaos, and patterns that were always there, hidden. 3i Atlas has changed how we see the sky. Not because it proved anything definitively, but because it forced us to ask questions we'd stopped asking, to consider possibilities we'd dismissed, to acknowledge that our understanding of the cosmos remains, despite centuries of progress, profoundly incomplete. We don't know if we're alone. We don't know if something watches us from the dark between stars. We don't know if the visitors that pass through our solar system are mindless rock or something far stranger. But we know we don't know. And that knowledge changes everything. It changes how we interpret every future discovery. Every odd astronomical observation will now carry a question mark, natural or designed, random or intentional coincidence or pattern. It changes how we think about our place in the universe. The comfortable assumption that we're isolated, protected by vast distances from whatever else might exist out there. That assumption is harder to maintain now. Because distance doesn't protect you from something that's willing to travel for millions of years. Patience, not speed, becomes the ultimate technology. It changes how we think about detection. For decades, SETI has listened for radio signals, assuming advanced civilizations would broadcast their presence. But what if they don't? What if intelligence has learned that the galaxy is a dark forest, where revealing yourself is suicide? In that case, you wouldn't transmit. You'd travel silently, disguised as natural phenomena, observing without being observed. You'd become indistinguishable from the background noise of the cosmos, and we'd walk past you 1,000 times without noticing. Perhaps that's what 3i Atlas taught us, that the real test of intelligence isn't whether we can build radio telescopes. It's whether we can recognize intelligence that doesn't want to be recognized. The philosopher Ludwig Wittgenstein wrote, "The limits of my language are the limits of my world." We can only think about what we have words for, only perceive what our frameworks allow us to perceive. For centuries, our framework for the cosmos was mechanical. Planets orbit according to Newton's laws. Stars burn according to fusion physics. Objects in space are either natural or artificial, alive or inert, intelligent or random. But perhaps the universe doesn't fit our categories. Perhaps there are things that are all of these and none of these. Phenomena that exist in the spaces between our definitions, visible only when we stop insisting they conform to our expectations. 3i Atlas might be such a phenomenon. Neither fully natural nor fully artificial. Not alive in any biological sense, but not inert either. Not intelligent by our standards, yet exhibiting behaviors we associate with intelligence. A liminal thing. Existing in the threshold between states. Every culture has stories of threshold beings, spirits that dwell in doorways at crossroads in twilight hours between day and night. They're dangerous in folklore because they don't follow rules. They exist in the places where rules break down. Perhaps the cosmos has its own threshold beings, and 3i Atlas is one of them. Or perhaps we're seeing patterns that aren't there, meaning where none exists, intelligence in randomness, because our brains are wired to find it. Perhaps in our loneliness, we're inventing companions in the dark. Both possibilities are terrifying in their own way. If we're alone, the universe is emptier than we imagined. If we're not alone, the universe is stranger than we imagined. There's no comfort either way, only questions spiraling into more questions. But here's what we can say with certainty: something passed through our solar system, something from interstellar space, something that behaved unlike anything we've seen before, something that left behind patterns we can't fully explain. Those patterns exist in data, in archived observations, in measurements that can be reproduced and verified. Whether they represent something artificial or merely something natural we don't yet understand, they're real, and they're waiting for interpretation. The physicist Richard Feynman famously said, "I would rather have questions that can't be answered than answers that can't be questioned." 3i Atlas gave us questions. Beautiful, maddening, persistent questions that will haunt astronomy for decades. Was it designed? We don't know. Will it return? We don't know. Are there others? We don't know. But we're watching now. Really watching, with instruments and minds tuned to possibilities we dismissed before. And that vigilance itself is perhaps the real legacy of 3i Atlas. It woke us up, made us look at the sky with fresh uncertainty, reminded us that discovery requires admitting ignorance. The ancient Greek philosopher Socrates was declared the wisest man in Athens because he alone admitted he knew nothing. That awareness of ignorance was wisdom itself. We know nothing about 3i Atlas. Not really, not definitively. And that awareness might be the beginning of wisdom about what shares the cosmos with us. There's a famous etching by Francisco Goya titled, "The Sleep of Reason Produces Monsters." It shows a man collapsed over a desk asleep while creatures of nightmare swarm around him. Owls and bats emerge from darkness surrounding his dreaming form. The traditional interpretation is cautionary: when reason sleeps, irrationality takes over. Superstition breeds in the absence of rational thought. But there's another reading, less popular but perhaps truer. That reason itself is a kind of sleep, that our rational frameworks, our scientific categories, our insistence on clear definitions, these create their own blindness. They filter reality, showing us only what fits our models, screening out everything that doesn't. And when reason sleeps, when we relax our rigid categories and allow uncertainty, the monsters appear. Not because they're newly created, but because they were always there, invisible to our waking eyes. Perhaps the creatures in Goya's etching aren't nightmare. Perhaps they're reality finally visible. 3i Atlas appeared when our instruments were watching our models, running our reason fully awake. And we couldn't explain it, couldn't fit it into our categories, couldn't decide what it was. Perhaps that's the point. Perhaps the universe doesn't fit categories. Perhaps reality is always stranger than our models, and the only honest response is wonder mixed with humility. The medieval mystics spoke of docta ignorantia, learned ignorance, the wisdom of knowing that you don't know. They believed true understanding begins when you abandon the pretense of understanding. Modern science has its own version, the Socratic method. Hypothesis, test, revise. Never claiming final answers, always remaining open to being wrong. But there's a tension between those approaches. Science seeks to eliminate mystery, to explain, to understand. Mysticism seeks to preserve mystery, to experience it, to acknowledge the limits of understanding. 3i Atlas sits in that tension. Science can catalog its properties, measure its behaviors, model its trajectory, but the mystery remains. What it is, where it came from, what it wants, if anything. And perhaps the lesson is that both approaches are necessary. Science to gather data, mysticism to remain humble about what that data means. We need instruments and equations, but we also need to admit when instruments and equations aren't enough, when the phenomenon exceeds our ability to comprehend it fully. The Zen Buddhist tradition has a concept, beginner's mind, approaching every situation with openness, free from preconceptions. An expert has many answers, a beginner has many questions, and questions often are more valuable. If we approach 3i Atlas with expert mind, we force it into categories. Comet or spacecraft, natural or artificial, threat or curiosity. We demand it explain itself in our language. If we approach with beginner's mind, we simply observe. Allow it to be what it is without insisting it conform to our expectations. Learn from it rather than about it. That might sound mystical, anti-scientific even, but it's actually the heart of good science. Observation before theory, data before conclusion, humility before certainty. The astronomer Carl Sagan wrote, "Somewhere, something incredible is waiting to be known." Perhaps that something passed through our solar system in 2025. Perhaps we caught a glimpse of it enough to know we saw something, but not enough to understand what. And perhaps that's exactly as it should be. Perhaps first contact, if that's what this was, shouldn't come with clear answers. Shouldn't be obvious, shouldn't make sense immediately. Perhaps the universe introduces itself slowly, in fragments, in ambiguities, testing whether we're ready, not for answers, but for better questions. The Lakota prayer says, "Mitakuye oyasin," all my relations, everything is connected. The boundary between self and other, between human and cosmos, between observer and observed, these boundaries are illusory. When we watched 3i Atlas, it watched us back, not with eyes or instruments necessarily, but through the simple fact of observation itself. Every measurement changes what's measured. Every act of watching is a form of interaction. We're not separate from what we study, we're part of it. Our observations, our questions, our debates about whether something is natural or artificial, all of this is part of the phenomenon itself. 3i Atlas wasn't just an object passing through. It was a mirror, reflecting back our assumptions, our hopes, our fears, showing us what we expect to see and forcing us to confront what we can't explain. And in that reflection, we learned more about ourselves than about it. We learned we're afraid of being alone, but also afraid of not being alone. We learned our science is powerful but limited. We learned the universe still holds mysteries that can humble us. Most importantly, we learned that we're still capable of wonder, still able to look at something and admit we don't know what it is, still willing to question our certainties. In an age of information overload, where every question can be answered with a quick search, where expertise is just a click away, the existence of something genuinely unknown is precious. 3i Atlas gave us that gift. The gift of mystery. The gift of questions without easy answers. And as it fades into the outer solar system, pulsing its 28-day rhythm, adjusting every November 1st, possibly preparing to return in decades to come, it continues to give that gift. Because even if we never learn what it was, even if it escapes beyond all observation and becomes just another archived mystery, it's changed us. We look at the sky differently now. Every point of light carries possibility. Every anomaly might be significant. Every comet might be something more. The universe has become, in a very real sense, larger, not in physical dimensions, but in potential, in the space it leaves for things we don't understand. And that larger universe is a more interesting place to inhabit. So as you drift towards sleep listening to this story of mysteries and questions, remember the darkness between stars isn't empty. It's full of possibilities we're only beginning to perceive. Something came from that darkness, brushed against our sun, and returned to the void, leaving behind only patterns in data and questions in minds. Was it natural? Was it designed? Was it alive? In some sense we can't comprehend, we don't know, and that's beautiful, because knowing everything would mean there's nothing left to discover. And a universe with nothing left to discover would be a dead universe. Ours is still very much alive, still full of wonders, still capable of surprising us. 3i Atlas proved that. Somewhere out there beyond the orbit of Neptune, something pulses.
Something waits, something that came from the stars and might return to them or might stay watching with whatever it has that serves for eyes. And here on Earth we watch back, with telescopes and mathematics, with wonder and uncertainty, with hope and caution in equal measure. The conversation has begun, not with words or signals necessarily, but with presence.
With the simple fact of existing in the same cosmos subject to the same physics, sharing the same dark between stars. And perhaps that's enough for now. Perhaps the first word in any meaningful conversation is just, "Hello, I see you. I don't understand you, but I see you." And then the waiting, the listening, the watching, to see what comes next. The universe is patient. It operates on timescales that make human lives seem like heartbeats. What happens over decades or centuries is to the cosmos an instant. We're learning to be patient too, learning to watch not just for years, but for generations, to ask questions that might not be answered in our lifetimes, to plant trees whose shade we'll never sit under. That's what 3i Atlas taught us finally, that some mysteries unfold slowly, that understanding comes in layers, that the really important questions can't be rushed. So we wait, and watch, and wonder. And in the waiting, in the watching, in the wondering, we're already changed. The sky is no longer just backdrop, just scenery, just the space between destinations. It's active, it's alive with possibility. It's home to things we're only beginning to perceive. And every clear night when the stars come out and the darkness deepens, we look up with fresh eyes, searching for the next visitor, the next mystery, the next impossible thing that will force us to expand our understanding one more time. Because that's what intelligence does. It seeks, it questions, it grows, and somewhere in the darkness something else is doing the same. We're not sure if we're watching it, or if it's watching us. Or if perhaps the distinction doesn't matter. Maybe watching and being watched are the same thing from a cosmic perspective. Maybe the real conversation happens in that reciprocal gaze, subject and object becoming one. That's a thought to carry into sleep.
The idea that observation itself is connection, that every time we point our instruments at the sky, we're not just studying distant objects, we're reaching out, saying, "We're here, we see you. We don't understand yet, but we're trying."
And maybe, just maybe, something out there appreciates the effort. Sleep well. The universe is vast and strange and full of wonders we're only beginning to glimpse. 3i Atlas was one of them, but it won't be the last. The age of mysteries hasn't ended. It's just beginning. And that's something worth staying awake for. Or paradoxically worth dreaming about, because sometimes the best insights come when reason sleeps and wonder takes over. When we stop insisting the universe makes sense and simply let it be what it is. Strange, beautiful, terrifying, magnificent, full of things that move through darkness, leaving only patterns behind. Things like 3i Atlas. Things like us, both reaching through the void. Both seeking connection, both hoping we're not alone, and in that hoping making it a little less likely that we are. The watching continues. The mystery persists. The questions multiply, and somewhere beyond Neptune every 28 days something pulses. Steady, patient, eternal, like a heartbeat in the dark, or a promise yet to be fulfilled. Sleep now. The stars will still be there when you wake. And so will the questions.